still entering the room. I want to welcome you to the Leipzig Semantic Web Day, to the 11th Leipzig Semantic Web Day, part of the Data Week 2023. This Data Week is the 11th, as I said, and we have quite some tradition of Data Weeks. So the Data Week started in 2010, so 13 years ago already. And since then, we had various topics around data and the semantic web in specific. And we had always had a focus on the local community in Leipzig, but also on the broader data community. And during Corona, we even made the event international and had participants all over the world. Not all over the world, but from other places in the world. And yeah, last year we established the Data Week, and this week we have the second Data Week, and we are very happy to be there with the Leipzig Semantic Web Day at the Data Week. The organizers of the Data Week are shown on the slide. So we had a working group that's more or less informal, AKSW, that made a big network. Essenza is a company providing the corporate memory and many other things. That's my employee. And I think many of you know the Essenza already. Then we also have the INFI, an attached institute to the university, doing research projects. And DBpedia, I think, I don't need to tell you what DBpedia is if you're in the semantic web. And HTWK is our local university for applied science. And we also work together with the Technische Hochschule in Brandenburg University of Applied Science. The program for today is quite packed, as you can see over here. Now I will guide you through the program of the day. We're now at the welcome. After my introductory slides, there will also be a lightning talk by Alejandro, then followed by our keynote by Felix Sasaki. And after the keynote on large language models, which I think is a very important topic at the moment, data and knowledge in the virtuous circle, we will have a break. And the breaks are not just time in between talks, but we also have a task for you, because we also have quite some students from the Leipzig University for Applied Science who have prepared posters. And that's also a part of our tradition at the Leipzig Semantic Web Day, that we also welcome the students from the universities and the universities for applied science to present posters with their work in their semantic web courses. So you're asked to vote with your dots, which you will find on the back of your name badge. You have a green dot and a red dot. The green dot is for the Best Semantic Web Poster Award, and the red dot is for the Best Designed Poster Award. And so please distribute your dots throughout these breaks, and visit the posters, and also chat and have coffee and cake. After this break, in the 10:15 to 12 session, we will have a session on ontologies, tools, and data acquisition for knowledge graphs, and with 5 presentations, followed by minutes by the future knowledge experts, which are the students from the universities and universities for applied science, who will then give you a short introduction into the topic of their slides, of their posters. So in the next break, you will be even more informed to distribute your dots if you didn't make your decision at the first break already. So pay attention to the posters in the break as well. After lunch, we'll have a session on knowledge graphs, use cases, and their applications. So how can we actually use them? And I forgot to mention the chairs. So this is chaired by Sabine Gründerfahrer, sorry, not in the room. And the other session is chaired by Kirill. Is he here already? No, okay, so he will arrive. And then at 2:30, we will have not the last coffee break of the day, but the last chance to distribute your dots for the posters. The students will really appreciate having your dots on their posters. And here you can have a final sight on the posters and maybe already guess who will win the poster award. And then in the last session, we will speak about semantic technologies and artificial intelligence. I think one of the main burning topics. I will chair the session, and then we will finally have the poster awards and closing ceremony moderated by my colleague Sebastian Tramp, and then we will hand out the prizes, and the prize is sponsored by Essenza, and it will be 100 euros each per poster, so choose well, or choose wisely. And then we will have another coffee break. You hopefully have no dots on your badge anymore, and but now you can look at the winning poster and speak with the winning team, have a last coffee, and then you will have some time to relax, to go through the parks in Leipzig, before we meet at 6 in the Moritzbastei for the Essenza Semantic Beer Garden. So this is also sponsored by Essenza, and we will meet in the Moritzbastei, so we are over here at the Rathaus. Okay, don't see it, you see my mouse. At the Rathaus, so you just have to walk along this nice park until you see some, I think, middle-aged fortress where we have a bar with a long student tradition, and there we will have beer and what else? And chat. And finally, I also want to introduce you to the Leipzig Semantic Web Day team. So that's me, Nathanael, Andreas Both, he's not in the room today. Julia, I think you see her around. She also does a great job for the Data Week in general over there. Michael Martin is not yet here, but he also does a great job for the Data Week in general. Professor Vera Meister, she's also not here today. Professor Thomas Riechert, I think, will arrive later. He's the professor at HTWK with many of the students who present the posters. Nieves was just in the room. She is over there. And Sebastian Tramp over there. So now we will have the lightning talk by Alejandro, and after the lightning talk we'll have the keynote. So please come here.
Thank you all. I wanted to start my talk. I know most of you are familiar with the topic of semantics, but I also know for a fact that some of you are really at the introductory level. And we'll be talking about semantics in the next room, in room 259, during the whole day, talking about what we at OGC are doing for semantic interoperability. I'd like to start by doing a really quick introduction to semantics. When we talk about semantics, we're mainly talking about RDF and a core set of principles such as assigning identifiers to almost everything, to real-world things, to abstract concepts, to documents, properties, whatever, everything except plain values, what we'd call literals. We defined the world using triples of subject, predicate, and object, linking either concepts or objects to their properties via a predicate. We're all familiar with the concept of a hyperlink, in which, for example, when we're on Wikipedia, we click on a link and those two articles are linked together. But the link has no meaning. For a human person, the meaning can be derived from the context, from the text around the link, or from the text of the link itself. But for a machine, that's not really possible. So we add the meaning through the predicate. And we link those resources, we end up having a graph. Those properties, those entities, end up being part of what are called ontologies, which is just formal ways of representing knowledge. They can be as simple as controlled vocabularies, just sets of terms with they can be nested into hierarchies, or they can be full-on ontologies with properties, restrictions, actions, etc. And that's one of the key points of one of the key benefits of using semantic data and using ontologies is precisely that common ground that arises from using well-known ontologies and extending those well-known ontologies. The result is interoperability. For example, if we want to define that something is an observation for the weight of a jellyfish with a result of value 100 unit grams, all those terms that I've highlighted in there can be defined in an ontology so that a machine can understand the meaning of that expression. So what is the OGC rainbow, which is the main topic that we're going to cover throughout the day in the next room? The OGC rainbow is a semantic interoperability environment for fair data. Fair data, I think we all know what FAIR stands for: findable, accessible, interoperable, reusable data. The OGC rainbow can handle a rich set of resource types. It can consume and produce several different types of data. We can do data visualization. It helps especially in linked data discovery, the F and the A in FAIR, findable and accessible. And it supports, it sets up a whole range of CI or CT or CD practices for standardization, starting from importing data in its native form, transforming the data, doing a semantic uplift, adding semantic information to source data, enriching or applying entailments to that data, validating that data, and then taking care of either storage for visualization or upload to third-party data or metadata repositories. We at OGC host a core node of the OGC Rainbow with several resource types. We have definitions, documents, data models, specifications, because we have found that even for an entity such as the OGC, which is focused on interoperability, sometimes it's hard to find relationships, to find common stuff between standards. Sometimes some of these standards will have overlap with other standards, and we may not know that beforehand. So the OGC Rainbow helps in that regard, in having a centralized node where we can look up, we can keep all that data. The data is available, as I said, as FAIR data. It's findable through text search, through navigable links. It's accessible. Everything is published through HTTP. We're using content negotiation, but also content by media type or by profile. Data is served as either HTML or with set of machine-readable representations, mostly scores versions in RTF, JSON-LD, plain text, nested lists. And it's reusable. There's actually a body inside the OGC called the Naming Authority, which is in charge of defining these identifiers, defining identifier namespaces, so that the links that are hosted at OGC are as permanent as possible, and content is freely available. We're also working on having a different set of nodes for hosted data, for staging because right now we only have the two development and production instances, but we're working on having an staging instance, a sandpit, so that people can work on their own data and see the results of the transformations before they go live. What I have here is a chart of how data is consumed and published by the OGC Rainbow platform. Data is mostly kept inside Git repositories. That data can be downloaded periodically, or it can be added to the repository via Git commits. Data is imported if it's necessary, and semantically uplifted if it's not already in semantic format. It's then entailed according to a set of rules and validated as well. Then it's serialized into several different formats, mostly Turtle and JSON-LD, but we have other formats available, and then pushed to a triple store, where it's served by a back-end and front-end tandem application. We're also, in the context of the OGC Rainbow platform, we're making several resources available for developers, such as Python modules, Docker containers, GitHub repository templates, an online playground, which we're currently developing, Jupyter notebooks to showcase all of this stuff, and we'll see all of this, as I said, throughout the day. And we're also going to be talking about location building blocks. Building blocks, pieces of reusable patterns for common interoperability problems, data types, query parameters in APIs, paths in APIs, or full APIs as well, such as a B-box. What is a B-box? How do you, when you define a B-box, a bounding box for geometry, how do you specify the coordinates, in which order, how many coordinates should you have, etc., including documentation, references, examples, to serve as a starting point for when a developer wants to start working on an application and can reuse these little pieces of these reusable patterns. And that's it for me. Thank you.
I don't have questions for lightning talk, right? Or you want to add something? Felix? Felix?
Is that working? Right. I just want to clarify that by presenting the program in the morning. So it has neglected that there are 4 workshops on semantics throughout the day in the room 295, and you are very welcome to join there. Right.
Okay. So, thank you very much for having me here, for having the opportunity to talk to you about large language models, data and knowledge, a virtuous cycle. And the image, what you see here, who knows who this is? Who has seen this guy? Somebody who is deep in hypertext may have seen this. This is Vannevar Bush. People say this is the father of hypertext, which you could say is, well, the grandfather of the semantic web. And it shows the machine, the mimics. which allows to interact with vast amounts of data and turn it into knowledge. And the message I want to convey here is that this virtuous cycle of using large language models and knowledge graphs together can contribute to realizing this vision. So first I will have a bird's eye view what will change for us when we talk about large language models, and then take two perspectives, one from knowledge graphs, how they can benefit from large language models, and then the other way around, how large language models can benefit from knowledge graphs. Then I also will give a few insight what's currently happening in this area related to knowledge graphs on its own at SAP and also to large language models. Of course, without, as usual in large companies, saying that this has any formal messaging. These are just my own views here in my presentation, also related to the SAP activities. And then I finish with a conclusion. And this presentation is all my own responsibility, but I got a lot of feedback from colleagues listed here, which I want to acknowledge before starting. So what will change for us? First, to set the stage a bit, when I was invited to give this talk and we discussed the title, large language model was really, well, a topic which everybody had in mind. Now we have a more broader view. We talk about generative AI. And I want to put this here in context for the focus of many what I things I say are, well, for both actually. So generative AI is about generating content using large AI models. And you can do this with images. So here the input of these images is a prompt saying, have two teddy bears talking about AI technologies in 1990 underwater. So this is what comes out of that. But you can also generate music using generative AI or code. So when you do programming, you probably have stumbled across GitHub Copilot. And you can create other types of text. So foundation models are the means to generate this type of content. And one key aspect of these models, also for large language models, is that they can adapt it to various unforeseen tasks, which really revolutionizes the way we have done, well, I would say both the work with AI, the statistical approach, but also the way we work with explicit knowledge modeling, with adaptability to new tasks. And large language models in that way are just one way of having generative AI with textual content. And as I said, this will change many things, including our jobs. So many people say, oh, we all will lose our jobs. Nobody will be needed anymore, especially in knowledge-intensive areas. So you see statistics like this one here from Goldman Sachs, which says that this is a huge change for the economy in many knowledge-intensive areas. And there are concrete examples where you could say, okay, these changes from large companies already are because of this AI disruptive development. So the numbers you see here are from a study which is about the effect which the foundational AI models may have on the labor market. So some people say 80% of the workforce in the US may change of what's happened here. And there are some concrete examples of recent layoffs. Google has done a layoff in the area of digital assistant. And you could interpret this layoff as a direct result of this. So the approach of digital assistants of Google so far and many others to do explicit modeling of assistants, right? So you explicit model a dialogue. But Google says, well, now this is needed less and less. You can just put your content in front of a large language model and then you can work with it. So this is really disruptive innovation. One of the sources I point here out emphasizes this development of digital assistant from, let's say, the knowledge-based digital assistant to the large language model-based one. And of course, this still has many issues. If you follow the discussion also in our community, you maybe have seen, for example, the keynote from Danny Vanditich at the Knowledge Graph conference, who said, it has issues like hallucinations, costs, and missing explainability, and so on. So these are still issues, but the change is there, the disruption is there, and it will have an influence. It will have an influence on job profiles. So it does not only influence the way we create digital assistants, from, let's say, the knowledge-based one to the large language model-based one. Similar disruption has happened before, so in the translation industry. Before the rise of machine translation, you just had translators. Now, already for many years, you have pre-editors and post-editors. And they are part of a workflow combined with the automation. So it doesn't mean that the job of people working in the knowledge industry and working on content creation goes away, but it changes. Maybe it changes from people creating content from scratch to people curating content. And that curation, and that's when the core of our community here, may involve also data models, or when knowledge graph created based on these data models, working with structured and unstructured data and so on. So you will also see some examples of SAP where there are experiments already with generating data models and then instance data, not based on core knowledge graph technologies, but I think you get the idea where this may lead to. So now let's, after all these, kind of, maybe a bit frightening view where this may lead to, let's have a hopeful perspective. So knowledge graph can benefit from large language models, and I will try to give a few examples. And one key point I want to make is that large language models can be a user interface, a revolutionary user interface. Some people before have introduced a revolutionary user interface. So maybe you have seen this keynote from Steve Jobs where he introduces the iPhone, and that's what he said. What we have here is a revolutionary user interface which changes how we interact with information. And information may be, well, some messages I get from somebody I talk to, maybe information on the web, and so on. And one key aspect of this disruption is that the UI, which was before the introduction of the iPhone, had hard-built UI controls, the thing you call a keyboard. This totally changed. So you now have just a screen where the UI is totally flexible. I think this type of flexibility, that's one aspect. If you see the large language model as UI, what's happening now? Now let's look into what we do day by day, and what we also just saw in the lightning talk, what you do when you work with semantic technologies and knowledge graphs. So you do knowledge modeling, you do data mapping, validation and exposure. And if you take a view from the point of UIs, interacting with knowledge graphs still for the non-experts is really a pain. So for many of these tasks, we have UIs, sometimes graphic UIs, but for example, for querying a knowledge graph, I would say there's no decent graphical UI which really scales, which really is also possible, accessible for non-experts. So this is, I'd say, the current state of UIs for knowledge graphs and semantic technologies. Now, how they, actually it's, I would say, the presence already, if you see what various vendors also do in experimentation, how does it look with large language models? So you can do modeling by creating a prompt, just saying what model you want to create. And you could do the same with data mapping, say how you want to map data sources and so on. So this does not mean that also a user completely defines a prompt. A lot of this aspect, that's a key message I want to convey, is engineering. The same way we do knowledge engineering in the background and the user doesn't know what's happening, people are now doing prompt engineering in the background and the user may not know what's happening. And you will see the same also in an example from SAP I will show later. So this was, the perspective, okay, large language models may help as an UI for tasks in working with knowledge graph semantic technologies. Another added value may be that you actually get more knowledge graph content based on large language models. Here I want to show you an experiment I made. I made a query to Wikidata about Danny Vandertich. The query is actually very general. So I just have to say, give me about this entity all information you have. And what you get back is, of course, a table with all information about Danny. What I then do is putting this query into a prompt, and you could say the prompt engineering part is here to write what you see on the slide. So I write what the large language model should do. This is kind of the dynamic UI generation part. This sentence, this prompt kind of generates a UI from the new application, and what I do now is I give into this UI the information I got from Wikidata and generate a multilingual summary. And if you look at this summary, I would say it's not too bad, and it's very close to the facts that you have actually in Wikidata about Danny. And if you look into the Japanese summary, well, at least I can claim that it's really covers the same content as the German one. There are some slight differences, and also as the English one. The English one is also not perfect. You see it talks about West Germany, so that's not kind of up to date. The Japanese one just talks about Germany. So there are still differences, there are still things to improve with, but that's a point I want to make. The roles then of people dealing with content change. In the past, you had to create these summaries from scratch. And if you say, I want to add a summary to my knowledge graph of what an entity is about, you write it from scratch, right? Now you can say, I become a curator. I have existing data, I have the summary generated, and then I just have to revise it. I may also use automatic methods like that, who detect entities like West Germany and say, no, this doesn't fit here anymore, and help me to cleaning this up. So the roles shift from a content creator to a curator. And the prompt, as I said, is the generation of a dynamic UI. So that was perspective how knowledge graphs, semantic technologies can benefit from large language models. And now I will take the perspective the other way around, how large language models can benefit from knowledge graphs. And here I just want to highlight some developments in this area. If you follow, well, even not closely, just on social media, what's happening in this space, the speed of new development is, it's just hilarious. So you get in certain libraries new functionalities every day, new ways of dealing with large language models, like the prompting I just said, when the so-called agent-based approach or function-based approach, and so on. So it's enormous what's happening, but slightly architectures-wise, architectures like what you see here on the slide. I don't go into detail of this architecture, that would be another talk, but I just want to highlight where in these architectures, and that is when the task, knowledge graphs can provide value. They can provide value as input, and you could see the example I just gave as one type of input. So the structured information you get out of a knowledge graph can be an input to the prompt. So that's what I basically just did in my example. This is also called few-shot approach to a large language model. So you give it some data. So not say just tell me something about Danny, but you give it some data, and then you get immediate results. So you can also see other types of input processing. I also go more into detail later. But it also can help knowledge graphs and the output. For example, validation. Remember what I just said about West Germany appearing in the generation about Danny. If I have a knowledge graph who says, no, I should talk about this entity as Germany, not as West Germany, then that could be used for validation. So I think there are many opportunities. If you follow these libraries which are being developed, like LangChain or others, if you played around with large language models, I'm sure you have come over it, you see that there's not much there yet, but there's an opportunity also. So for example, people have created an SQL agent to query an SQL database. Why not query a Sparkle agent? So this is also kind of a call to look into these communities and see how to make semantic technologies workable in these architectures. I want to give another example of the added value of knowledge graphs, coming back to my prompt I just said. And this time I have a prompt without the knowledge graph. And again, I create a summary. And what you see here is I guess, what many expect. It's full of hallucinations. So, for example, this output says that Danny is still working at Google, which is not the case. What you have seen before, this is an output which is much more accurate, where the output is really based on the actual data in Wikidata. So the role kind of shifts from a large language model to be the actual content, where you ask a question to become the UI, as I said before. And another figure in this space, which looks a lot into large language models and knowledge graph, is Dean Ellerman. So if you look into this blog post, he phrases this as figuring out versus telling. So the knowledge graph is meant for figuring out what is actually information I want to work with. The large language model is then meant to tell the information for various users and in various languages, and to also provide new scenarios. So what's called here, this way of using large language model is retrieval augmented generation, and there's also related research linked from the slides about that. So one key part what you need for large language models is, of course, training data. And another hypothesis I would make is that this training data can benefit from the information available in knowledge graphs. As everybody in this room knows, I would say the web is already a large knowledge graph. If you look at statistics like here from Web Data Commons, the percentages of web pages which have structured data based on schema.org, based on the knowledge graph vocabulary. So if the large language models take this into account, then they ought to benefit a lot from the knowledge graph. To me, that's still also an open question. What really is taken into account here, also because, especially in latest model, there's no clear transparency how the training works. But I think there's clearly an opportunity how a large language model, by just doing the training, can benefit from the knowledge graph. I want to come back to my example again, just to highlight another aspect. So in my example, I showed how the large language model can be used to verbalize what we have in Wikidata. And I just want to point out that this can also be used to create high quality training data if you feed the output back into the large language model. Of course, this may have issues like what I mentioned before, hallucination, and then another issue if you have such a cycle of feeding back data in is always overfitting. Of course, so you have to be careful about these aspects. But again, if you see this just as an aid, where still a curator in the loop to help with data quality, then it may be an enormous help for me to create more content also for training data generation. So these were like the two perspectives, large language models and knowledge graphs, how they can benefit from each other. Now I want to highlight some recent activity in SAP about these topics. Again, without saying that what I say is complete or has any role of definiteness. What I highlight here are two projects which are active in SAP and which are not related to large language model. I would say this is the classical way to work with knowledge graphs and semantic technologies. One area is Signavio, which I think also people work in process modeling know as a way to do process model definitions. And here a knowledge graph is being created which captures process knowledge on a semantic level. Another area is the so-called situation handling activity, where as part of a major project from SAP S4, situations, critical situations like some customer doesn't pay or things like that are detected automatically, and then the knowledge graph can be used to deep dive into the reasons of these situations. So this knowledge graph encodes lots of parts of the SAP data model, and that helps with deep dive for business users who normally don't understand the data model. So these, I would say, are classical ways to use knowledge graph, which are now happening also in SAP. There are also activities related to large language models, we're not yet aware on using native knowledge graph technologies, but we use, I would say, the same approach. And I think you can map it this one-to-one also to semantic technologies in knowledge graph. So what you see here is a workflow of a demo where an SAP data model in the so-called CAP development environment is generated with a general pre-trained transformer, so with a large language model. As an input, we have again a prompt. So the prompt describes the application here, what it should do. And the first output of the prompt is the generated data model. So here you see just a part of the data model. It's about a ticketing system, and here you see the definition of the ticketing system. And if you follow this video, I can share also the slides later, you will then see that also a UI is generated automatically. So this, of course, does not work perfectly out of the box. And one crucial aspect here is that the way we interact with large language model is not just a one-time interaction. What I mentioned before, these so-called agents are a means to allow the large language model itself to decide, is a generated data model already perfect? Does it follow some validation requirements and so on? And iterate on itself until the requirements are fulfilled. So I encourage you to look into this because I think it can be very inspiring also to map the same workflow for working with semantic technologies and the related standards. Another area is in the area of process management. This is, again, technology-wise away from large language models, from knowledge graphs, but I still want to mention this here because, again, you could see process management and process modeling as one way of knowledge modeling. And I think a lot of ways to do this can be learned from this existing work. And it benefits to aspects like process automation, summarization of processes, and so on. So, with that, I'm done with my talk and at the conclusion. And the big picture which I tried to draw when I was invited for this talk, the virtuous cycle, well, other people have come up with this as well. So this is from a recent published paper which I think got a lot of attention in the community looking into knowledge graphs and large language model. It kind of already depicts the virtuous cycle and many points which are made here about how these technologies can benefit from each other are detailed out in this paper. So I'd encourage you to look into this. And there are also many blog posts, people I mentioned from Dean Ellerman or Danny Vandertit's recording of this keynote. So I think it's really worth to look into this to get inspired and to see how these things can work together. But still, I want to draw my own virtuous cycle, which is here, and which takes up what I try to say. So large language model can be seen as UI to expose a knowledge graph, to augment a knowledge graph with a large language model, to generate new information, to use the knowledge graph as a data source, to augment the large language model, when also for large language model training. And so the cycle closes. So what does it mean for this community? I think it's really great, the lightning talk you give at the beginning fits very well. Fair data is really helpful to make this work. Because if you publish your data as fair data, because the large language models are based on data what's on the web, it already improves the quality of what's being created as large language model. And the last point I want to make is, again, see this as positively. These are changes, but these will allow us to make more tasks, to execute more processes and different processes, and to generate more content, like the multi-click content, which was not available before. So to come back to Vannevar Bush from the beginning, in his article he had separation of what he called repetitive thought and creative thought. And I would say this combination of large language model and knowledge graphs allows us to spend more time on creative thought. Thank you very much.
Felix, for your very inspiring keynote. And I forgot to introduce you, but I think you've shown your expertise already, that you've studied linguistics and Japanese, that you're also very involved with the World Wide Web Consortium. And now you're working at SAP.
Yes.
But before you were working at the TH Brandenburg with Professor Meister together.
Yeah, indeed.
Yeah, and so I think we saw your expertise in the talk very well. Thank you very much.
Thank you for
And I think we also can have 2 questions. So yes, please, microphone. Over here, Mike. Can you come to the microphone? Okay. We also have microphones here. Hello? Yeah. Okay.
Very good question. Really interesting talk. I just wonder how you deal with intellectual property rights on your training data. And how does that all work? Because presumably there's not that much open text without copyright.
That's definitely a challenge. So how to deal with these rights, and that's also a challenge. The way these models are trained, right? We're just trained by getting this data on the web, but this may actually turn into opportunity. So you see, for example, that legislations in Europe are now underway, which are much more strict. The opportunity which arises from this, if we focus on fair data and publish fair data really at scale, we have really a competitive advantage compared to people who just scrape everything, but who then may not be compliant anymore with the upcoming regulations. So I would say currently people don't take this into account, but again, I think there may be an opportunity by just follow what we already do, by putting this into practice and encourage also others to do so.
Question.
Thanks for the inspiring talk. Which language model are you using for your experiments? ChatGPT, like probably most of it, or open source models, Cloudy, Palm from Google, or something else?
So I cannot say anything about what SAP is doing internally, but me personally, I'm playing with ChatGPT or GPT-4. These models also with open source models. The example you just saw, the Japanese, German, English one, was created with GPT-4.
Thanks.
Okay. Yeah, let's thank the keynote speaker again. Let's thank you, Felix. So now we have a coffee break. Look at the back of your badges. Don't forget to stop by the posters, and then we will meet 1:15 again here in the room, and Kirill will chair the next session then. See you back here.
A lot of people still flowing in. Okay. Dear ladies and gentlemen, it's a great honor for me to chairing this 11th Semantic Web Day on the second Data Week in Leipzig. This session today will be regarded to tools, ontologies, and data acquisition for knowledge graphs. As we all know, the tools and ontologies are the key basic stones for knowledge graph building. And as I sneaked in today in different sessions, and yesterday in different sessions, I realized that most people are missing the tools, and that a lot of people are struggling with keeping up with all the data that's coming in. So we have a lot of data, but we are still lacking on tools to support those people. And with the results that the people are drowning in those data lakes that we created. So to keep the introduction short, our next speaker for today is the Professor Hoppe from the Fraunhofer Institute of Open Communication Systems. He will join us remotely. Professor Hoppe?
Yeah, thank you very much. At least I can hear myself, and so the transmission shall be okay. Okay, so unfortunately, I'm starting a workshop here in at Castle Darkstuhl on myself, so I can't join this session today, unfortunately. Okay, I was asked to talk a little bit about the Wissensgraphen project, and the issue I want to raise today is how do we model recurrent patterns in knowledge graphs. The context of this work is in the context of one of 6 AI crisis management projects funded by the Ministry of Economic Affairs and Climate Action. In order to give you a little overview of what we expect, I will talk a little bit about the background, where we do it, what the challenge is, and the approach we think could be feasible for solving this problem. And then I want to talk also about some technical issue, how we try to approach the problem. You know it all. Since 3 years, we are confronted with crisis, and we know that the globalization imposes big challenges on our infrastructures. We are engaged in a network of supplier-consumer relationships, and once these relationships get broken or get in trouble by some vessel which is stuck in the Suez Channel, as we all experience in 2021, we see that a lot of those supply chains get in trouble. We get a rush on ships on the ports. We get container jams. We have a delay due to lack of ship containers, and the supply chains are in trouble. Even later, I made the translation. Some Chinese port paralyzed the shipping worldwide because the container were stuck there. No ship could get loaded and unloaded. And of course, in the future, the situation will get worse. We get new disruptions by extreme weather caused by climate change. Water scarcity will become a problem. Droughts, famines, and migrations will get a problem. And of course, by fires, floods, and landslides also, our supply chains can get interrupted. Oops, on further. So what we are doing in this Wissensgraphen project, which stands for Resilient Crisis-Relevant Supply Networks. First, we are developing some solutions for the support of crisis teams via drones in order to get an overview over the situation. Then we address communication with the citizens in order to inform them, to prepare them on the issues which need to be taken. Supply of blood transfusions is in general a problem because of the changing ages of the people. There are no suppliers, no Spender, I don't know the word in English now at the moment. Yeah. We have also the problem that the clinics are suffering in Germany from people who are working in the hospitals. That's one of the issues which need to be solved. Also to get the planning of operations for elective risk patients. But the main issue we intend to address is the supply of products, of crisis-relevant products, in order to analyze the supply chains and to make simulations. Okay. So what is the problem there? Of course, in some crises, we want to maintain the regular operation of, for example, healthcare personnel, of firefighters. So we need to track the development of the goods within the organizations. We need to identify supply bottlenecks, and we want, for that purpose, to adopt some kind of supply chain analysis. To make here, to state here the problem, show you here some visualization of a supply chain of an FFP2 mask producer sitting in China and Guangzhou. The good needs to be transported to Europe, usually by vessel, usually through the Suez Channel. We've taken the route over Genua and the Brenner to the fire department of Berlin. This is some visualization more or less intended to, or visualization of the Prof O formalization of this network. And our idea is now to identify alternative suppliers, alternative production paths, maybe also identify alternative countries from where we can get the goods, or alternative delivery paths. Here we have vessels. In reality, we could also use airplanes. In some situations, we could also use trains, but unfortunately, from Asia to Europe, there exists just one route for trains, and that's going through Russia. And of course, you all know it. It's impossible to get goods on this delivery path transported to Europe. So we want also to address different modes of transportation. And of course, these single supply chain had multiple points of this for possible disruptions. Here some visualization dated in red with the red dots, like for example, a vessel stuck on the channel, here a vessel stuck on some channel, maybe some problem in the harbor, maybe some problem at the producers. There are a lot of different kinds of disruption possible. And we started, and we have seen that, of course, no single expert can model this supply chain. No non-expert can model this supply chain. That's overwhelming task for him, and that's just one delivery path. We have different delivery paths. We have different suppliers. So the search space for all those analyses get incredibly huge, and we can't model that. What's worse, we can't even get all the information. We don't know which truck in China transports the goods from the producer to the harbor. Maybe we know some vessels which are going from Guangzhou harbor to Genoa. So our idea is now, since we have identified some recurring patterns, maybe we could use these recurring patterns because, of course, if we have a producer somewhere in China, the goods need to be transported to some harbor. And in general, that will be some kind of truck. The same situation holds, for example, for the harbor of Genoa. The goods will be transported by some truck, and we have different kinds of sea routes running from Asia to Europe. So why can't we do something like designing some kind of templates which can ease the production, the acquisition of all those data, of all those supply chains? The data are usually difficult to obtain. We can ask the firefighters here in Berlin what are their suppliers, but that's already the end. If we know the product, we maybe do some research in the internet to find the producer somewhere, but we don't know how the transport is organized. That's usually hidden, these tiers. But we can formulate hypotheses about them. We can formulate the hypothesis that there must be some truck and that there must be some vessel transporting the good. And so that's the idea now for our template-based approach for modeling that and for refining the knowledge graph. Is it too fast? Okay. So the idea now is to look at those parts of the supply chain, to formalize them in some kind of template mechanism, and to extend them by maybe some hypothesis. They need to be loaded somewhere. They need to be driven by someone. This someone is acting on behalf of some company, or it must act on behalf of some company, but we don't know it. Maybe we know who organizes the transport who's no, I don't know it in English. Yeah. So how do we prevent these some things? If we would do it in a logic, that would be easy. We would do some existent quantified variables, include them in our model, and that would be fine. But in RDF, we don't have this mechanism. The only mechanism we have are blank nodes. So let's look a little bit on blank nodes. There was an interesting study about the usage of blank nodes in the LOT and semantic web. Here, this billion triple challenge acquired a lot of 1.23 billion of triples in more than 8.3 million documents. And as you can see here on the statistics, blank nodes are used a lot. So that's quite interesting. And if we look at this, and the study looked at this, at the usage of those blank nodes in more detail by some questionnaire of 88 participants among the contributors with some multiple choice answers. They stated that 46% are for representing unknown entities, 24% are used for representing hidden entities, 2.3% are represented for maybe existing entities, and 37 points are used just to avoid to introduce unique URIs which are just used at one place. So that's a statement. Blank notes are used for unknown entities, for representation means, like for example, for representing in RDF lists and sets, for the anonymization and hiding of information in order to keep the information secure, and to avoid the introduction of unique URIs. So the conclusion is the semantics of blank notes is ambitious. They are not sufficient for representing unknown individuals assumed to exist. And so what are we doing now? We are looking at logic, know that there's some way to transform existentially quantified variables into Scholam contents, and we adopt that scheme for our templates by introducing a new URI scheme, XVAR, in order to mark them. I will skip that because I'm running out of time as I've seen it now. Here is some example of how we could imagine how those templates get used. Some information are input to the templates, some information are output from the templates. Here is our mechanism, and in red are these existential quantified individuals, which we call them in those templates. And from that, we can generate some knowledge graph with some Scholam constants for those unknown templates. And I think my time is over. Thank you very much. And of course, I'm available if you have any further questions about these ideas in the Wissensgraphen project. Thank you very much. Oh, you are muted. I don't hear anything. I can't hear you.
I will try again. Is the microphone maybe working? Hello?
Yeah.
Professor Hopper, can you hear me?
Yeah.
Yes.
I hear
Okay,
you.
we have time for one question. I give the audience the chance to participate. Has anybody? Okay. So, I have a question. Are you able, that's kind of strange to look at to his face, but he will see me through the camera. Are you able to collect the data you need for that? Because right now you have a template, but also do you have also the data? Because it's quite hard to convince the holders of data to, well, not even publicly, but share the data to make such a system a reality. Yesterday I talked with the biodiversity folks, and they have a lot of reservations to sharing the data because their endangered species might be even more endangered if it comes out where they live and so on. And for geostrategical reasons, your data is also quite critical. So is it possible, or is it kind of, well, very hard?
You got the point. It is extremely difficult. What I've seen is there are some companies which are giving their supplier data away. There's some site, Open Supply Net, I suppose, where you can get those data. Most of the data are really hidden. What is visible is usually the first tier. Those direct suppliers you can see, the others you can't see. So the only chance is now to work with hypotheses and to collect the data in the actual crisis, because then the data become available, they are visible, and then you can introduce them. And as long as we don't have them, we need to work with hypotheses. That's the point. There is maybe some change. I've read today that the Data Governance Act from the European Union allows in crisis situation to get the government to get access from the government on those data, and that might open some kind of door. But I think there needs to be done a lot on the government side still.
So also
That's
quite
it.
a social problem.
Yeah.
So thanks, Dr. Hoppe.
Okay, thank you
yes.
very much.
Our next speaker will be Dr. Chamanara from the Technische Informationsbibliothek Hannover, TYB. So, TIB. Slides. And make it short. So yeah.
Thank you.
The stage is yours.
Okay, thank you very much. Hello, everybody. I will be shortly talking about the project Databricks. That is basically bricks of data, so is a Lego of tools that we are going to play with. The idea here with the Databricks is that we have a collection of software tools, like they are doing different things, like data operations, machine learning, I don't know, face blurring, data analysis, and so on. So with this, then we have like a scenario or a process that we want to integrate these tools to each other so that they can collaboratively do something. And this something is going to actually realize a higher objective in accordance with a data-intensive project process. So basically we have a process like this. So you are designing a process that first I will do some experimentation with data, then I will validate my data, and then based on that, I will do the actual analysis, and later on probably I will publish the result and so on. So with this general things and the toolbox, so the set of tools, the process, what we want to do is that if you have a process defined with an existing set of tools, how do you do some sort of a recommendation to show that, first of all, what are the tools that can best satisfy the requirement of those processes? And second, if you can optimize this for something. So here in the project, we are interested in optimizing for energy consumption. It's like that, for example, you have, like you want to do activities, like for example, in case of face blurring or number plate recognition. Then there are multiple tools that can do this for you. So which one do you choose is based on your objective. And objective, if it's like for energy consumption, you will choose one tool. But if it's for performance, you will choose another tool. If it's for cost, you will choose another tool, or possibly you have no choice. So this recommendation is going to take the tool specification as input, and the process also as input, and then produce a set of suggestion or suggested tools. Like, for example, this with the workflow. So we will suggest the tools and how these tools should be bound to each other to satisfy the requirements of your process. It doesn't guarantee that it will fulfill all the requirements, but it will do the best possible satisfaction or fulfillment. So in addition to that, as I said, there would be a set of policies that are coming to check and also to control your recommendation process. Here we are interested in optimizing for energy, as I said, optimizing for cost, and optimizing for duration of the execution of your process. So for this, then we will create a deployment package from those tools, bind all of them to each other as a workflow, and then you can basically run that on a cluster or something, all the tools ready to be used. So what is the relationship here with ontologies and knowledge graph and so on? Is that let's say that the process we are developing a website that you go there, you design your process. So let's say, for example, here you design the process. So let's say, for example, you say at the beginning of the project, I'm going to do data discovery. So I will have different sets of data sets. Then I will do some experimentation with those data sets to see if they feel the requirements of my project, if their quality is good, if they have enough attributes, and so on and so on. So you will design all these things. And then in the second phase of your project, you say, okay, I will do this algorithm, that algorithm, this algorithm on top of that data. And then when I'm ready, I will publish it to somewhere, I will get a DOI, I will write a data paper on that, and so on and so on. So behind the scene, we know the relationship between these activities that you drag on your process surface and try to make the relationship with the tools that we have in our tool arsenal. So for this process that you saw here, behind the scene there is actually a knowledge graph For that knowledge graph, we are developing, actually this is started, to have an ontology that with this ontology you can describe the process, the activity that should be done in that process, and also their dependencies, like in terms of data dependency and in terms of time dependency between them. Like for example here, you say is a process, that this process has phases and has like working areas, which we call them disciplines, and then inside that there are different disciplines, there are different activities and so on. So with this, any organization that wants to use this tool will actually use this ontology to create their own process. So with the website that I showed you, you can create your own process, or you can customize one of the existing processes that are in the repository of the tool. With that, when you are finished with the process, let's say this is an example. With this, you create your own. You customize it. You can also add phases, activities, and so on. But we will actually provide a set of templates for different types of projects. And then when you are done with that, inside each tool, we have like in the consortium, we have like 25 tools that are under development. But this will act as a marketplace for tools that can be reused under different licensing patterns. So in case you have a tool, you can augment the tool with this tool specification. That is another ontology, I will show it. You provide the tool, you provide the services, you actually explain the service in terms of an RDF TTL file, attach it to it and send it to this web application. Inside that, we will actually create the cross matches between those services and what is on the processes. And later on, when someone wants to do something with the processes, we also include your tool or your service in the suggestions that are made by the recommendation engine. So an example of this one would be something like this. Here, what we are doing is basically like basic information about the software, basic information about the operation that the software is doing, and then relationship between this, that this is the duration of this operation, this is the time that it takes, this is the cost that it takes, and we have like a software benchmarking platform that we are measuring all the resources that are needed. Like for example here, we know that this operation, this single operation, will take 12 flops in terms of operating. It will take 10 milliseconds to run. It will take like, I guess, 1,500 nanowatts to complete. So with this information, the recommendation engine will use this to suggest you the tools that best satisfy the requirements of the process, and also optimize it for the objective that you have. Also, the resources that this operation will need are actually included in that specification. All of these things will be used by the recommendation engine and later on by the deployment engine. So when we are going to deploy this set of tools on the cluster, we will use this information to allocate resources to your workflow on the running cluster. So with that is, let's say, for example, here the input to the recommendation engine would be one of these knowledge graphs, like a mini knowledge graphs, and mini knowledge graph about the tool specification, and the rest you already know. Thank you.
Thank you. So, any questions from the audience? Well, this was quite a complex topic. So your ontology that you built, is it built on existing ontologies like Provo, or did you construct the ontology yourself? Actually,
we have started from scratch, but we have placeholders to be replaced with the existing one. And Provo is one of them. SSA we are using for measurements. And what else? We use DCAT for like software specification and people specification and so on. That's it. So we start from like a built-in house-made ontology, but we just replace them with whatever that we find out during the project.
Okay. And if you're replacing those ontologies, the values you're computing, like the running time, that is quite dependent on the architecture that it's running on, I guess. So how do you provide the cost if you...
We have a sandbox. Every tool that we accept to be listed there should go into that sandbox and be measured. And then they are basically the relative information about it. So this is not 15 nanowatts. This is something we call it nanowatt, but it's like virtually normalized with the others on that sandbox. So it's not real value, but it's comparable value.
Yeah, okay. And the last thing, if you have a recommendation engine running, how do you optimize for not only for the energy consumption, but also for the, well, quality of the results? Because
we basically don't really care about the quality of results. We just optimize for what we know. And in this case, it's like we are doing a multi-objective optimization using machine learning. Basically, we are applying reinforcement learning on top of that to find out. But the problem is that our data set is too small. So in many cases, we are just overfitting almost always is exact match. Mm. So
I was trying to figure out how to game the system. And so my approach would be to provide a tool that's very energy efficient, but does not produce any results.
Right, this functionality will be actually checked by another group in the consortium. So we have integration phases, we have functionality testing phases, and we have this benchmarking. But in general, that is right there, yeah.
Okay.
Yeah, that problem is there.
Yeah, the problem is there, okay. Yeah, thank you.
Thank you.
Thank you so much.
Thank you.
So our next speaker is one dear colleague of mine, Simon Bin from the INFA Institute of Efficient Technology. No, it's So you'll be talking about GeoSparkle queries on Apache Jena. Thank you.
Thank you. Welcome to my talk. I'm here with the Institute for Applied Informatics and supported by the Federal Ministry for Economic Affairs and Climate Action. And our goal today in my small presentation is how to combine geospatial linked data and semantic web. I also saw a lot of posters out there, so if there are any students in here, please take note how to model these data. And why might we want to do this? One example would be just to render the RDF content, the semantic web knowledge graph data, show it on some linked data viewers, like you can see here on the left side of the screen or in the Graph Explorer on the right side, so that you have any geospatial data attached to your RDF nodes would be immediately visible on a map as a shape of an area or as a point of a war, action, attacks, and so on. But we can even go further, and I'm just giving here some thoughts, and I'm sure you can think of more elaborate ideas. Could be to combine the geodata in the graph. So here on the left side, and you can see the Rio Grande together with all the states that it flows through before reaching the sea. And I have produced this map with the Sparkle query that you see in the top right. Or you could combine the geospatial information together with other information that you have in your RDF data model, properties that you have on your knowledge graph data, like, for example, ask the query which buildings in Utrecht Center were built before 1750, and it would be just a simple Sparkle query away with the help of GeoSparkle to contain these regions. So what do we need to do this? First thing is GeoSparkle, standard by the Open Geospatial Consortium, which is also participating in this data week this year. It's a standard for representation and querying of the geospatial linked data for the semantic web. So despite the name, it's also about representing the data in RDF, and it contains ontologies, properties, and functions to enhance your Sparkle queries to do this. and we will take a look a bit at the details. I just want to skip a bit over these slides, so if you look later on them, here is a technical usage. For our base, we will use Apache Jena, an open source semantic web framework for Java, which has GeoSparkle as an optional dependency, and you can use it either with a special GeoSparkle Fusiki server or by adding the dependency and configuring the Fusiki server yourself. I must say there are some limitations, like a static geoindex, which you should keep in mind if you play with this. And for a quick start, you can try these steps later on. You can use our RDF processing toolkit, which is a convenience package to work with RDF based on Apache Jena. You can run it with Docker or download the jar file or Debian packages from the website. So now, how do we present this geoinformation in our RDF data? You can see here I have put a drawing of the graph of a Germany node in RDF data, and this is a so-called geofeature, which has the property has geometry, and that links to another RDF node of type geogeometry, which then has another property SWKT, and there you see a weird list of numbers and the word polygon. So here we have this coordinate list as a custom RDF data type. You can see the turtle text representation in the background of Germany and the geometry. So what's up with this WKT thing there? So here we are using sub-languages inside of RDF. The WKT is another standard originating from the Open Geospatial Consortium, a well-known text format, text markup language for representing vector geometry. And here I have taken from Wikipedia some examples of the most basic and important types. Here we have points, line strings, polygons, and multi-polygons, and you can see the textual representation on the slide as well as the drawing on the map on the right. And to store this information, we need this RDF property SWKT, as well as this special data type WKT literal. As part of the GeoSparkle standard, you can also use different representations for your geometric information, like the GML, XML-based geometric markup language, but I won't go into detail on these other possibilities here. One thing I do want to bring to your attention is the spatial reference system or coordinate reference system. It is what is giving meaning to the numbers, coordinate lists that you have seen there in the examples. And if it's not specified in GeoSparkle, then it defaults to this RIUC here, OpenGIS Dev CRS 84, which is degrees on Earth. And this is the degrees longitude followed by the degrees latitude pairs of coordinates. And however, there is another very commonly used coordinate reference system, which is basically the same. It's called this EPSG 4326. And the numbers are the same, but latitude and longitude are switched around. So this leads to easy confusion, and we even found some data sets on the web which were like broken because mixed content, half of it in this and half of that in the other format. In RDF, you can always specify which coordinate reference system you are using in your data. So, and finally, sometimes the conversion to Euclidean spaces or metric spaces is necessary if you want to do some calculations. And I have also found on the internet some pictures of the United States in different projections. And now if you imagine you are trying to take this on a sheet of paper and do the area calculation of one of the states, you will see that immediately the size of the state will vary heavily dependently on which projection you used. So always try to find some projection which is close to the points that you want to do some calculation with before you flatten it on a sheet of paper, because of the spherical ellipsoid of the Earth sometimes makes it a bit difficult. Now, what functions are available in GeoSparkle for us to use? I want to show here some important ones which are pretty useful, like the buffer. You see an example here in the upper right. It adds a region around one of the existing shapes, so you can turn a point into circles and, for example, add an area around lines or polygons. You can calculate the distance between objects, or as shown in the bottom right corner, create convex hull or envelope, like a kind of rectangular shaped region around your polygons. And there are also some vendor or custom functions available in Apache Jena, like transform SRS. This will become a new standard function in the upcoming GeoSparkle 1.1 called transform, to do this important transformation of coordinate reference systems, as well as latitude, longitude, or simplifying. Also, what's very important is you have to sometimes want to answer the questions, like I showed in the introduction, which contains what. So there you can use these simple feature topological relations. There are more topological relations available in the standard, but I think here are the most important ones, like contains, overlaps, or touches, equals, crosses, that you can use in your queries. And finally, I just want to mention the upcoming GeoSparkle 1.1 standard, which is almost finished. GitHub link is here, and it will add many things like metric properties, area sizes, lengths, parameters, bounding boxes, even more representation formats like GeoJSON and KML, and it's also work on the discrete global grid system that is coming up. And with that, I'm happy to receive some questions if there are any.
Thank you, Simon. So, are there any questions from? Oh, yes, from the audience. Go ahead.
Yeah, thanks a lot. Just wanted to ask about another update, which is now ongoing, the update of the RDF family, you know, RDF star and Sparkle star. Do you think that that will have any influence on your work and on the capabilities you talked about, or? Yeah.
So this is a very good enhancement. Upcoming RDF Sparkle 1.2 standard with RDF star will add a lot of the missing property graph features to RDF. So thank you for the comment. I don't think it will affect GeoSparkle in any way. It will just be a compatible enhancement. So I'm looking forward to see what the community can do with all these things combined. Yeah.
Other questions from the audience?
Actually, I have one question about your talk. If I understand correctly, the Sparkle 1.1 you now support geocoding, right? That is translation from geocoordinate systems. Is that correct?
That's already exactly. That will be part of the upcoming standard. It's already available as a vendor function in Apache today. Yeah.
Okay, cool. And another question is, it seems to me that the main problem of all of this is because the ontology that was used for modeling geospatial data was created for people that I think there was no actually idea what geospatial data was, because there was this property WGS84 that everybody used to use. And like 10 years ago, I was already talking about this. You cannot use this in some places of the Earth because of the exactly things that you showed here. So is there another ontology that will be able to, is there already an ontology that is capable of incorporating the this parameter?
Yeah, thank you very much for the question. So this is exactly what I'm talking about. Please use GeoSparkle. Do not use any old WGS 84 ontologies. They are very limited. They can only store a single coordinate. They are not keeping the things that should be together. They attach directly some latitude and longitude to a feature, which is just very unfortunate. And here with GeoSparkle, we have even the possibility to represent coordinates on the Moon, on the Mars. So even though the engines cannot do calculations with these coordinates yet, it's already possible to represent and store them in the database. So yeah, very good information. Thank you.
We have to change the standard.
The standard already supports it. This standard already supports it. Just please don't use the old standards. Yeah.
So the last question.
Okay. Thank you. This is two mini questions. First, is like 2D objects only features, or 3D is also supported? And the second one is that, do you also support functions inquiries like distance of two features, or I don't know, volume, area, this kind of things, or even more complex functions?
Yeah, thank you. Thank you very much for this question. So, yeah, unfortunately, I have to give a mixed answer. Storing and representing 3D objects is already possible. This is part of the ontology as well as the WKT and GML representation format. However, for example, the Apache Jena engine is not yet capable of working with this data. So you can, it can only consider the 2D parts of your 3D elements to do the calculations. So the standard is there, the implementation, I'm not sure about the commercial ones, cannot say anything about that, but yeah.
Okay. Thank you, Simon.
Pleasure.
And also, thank you for providing a Docker container so everyone can play around with it in a simple way without setting up everything that sounded quite complex. So our next speaker.
So just one last comment on the slide, the last link, you can find very short steps. You can try a lot of things. Just follow the last link on the slide. It has Docker containers instructions. Yeah, thank you.
Thank you.
So,
our last speaker for the day, Konrad Höfner, you have the stage.
Hello, thank you very much for the introduction. I'm Konrad from Imise, and I will present WikView today. Some of you may already know it. It's a lightweight, standalone knowledge graph browser written in Rust. And the problem it's trying to solve is that when you're around for a while in the semantic web community, you have a bunch of small knowledge graphs. Some are lucky to be in a large project where you always work in the same, and you have an operational management where you can always maintain it. But often it's like you have 1 year, you have one knowledge graph, and then the next and the next and the next. And after a while, you have a lot of them. And then the question is, what do you want to do with all of them? Especially the old ones, the 10-year-old ones. Deployments break, the server shut down. You often have like ransomware attacks in Germany right now. And responsibility is often difficult. Like the project is over, the funding is over, the people work somewhere else, and no one wants to do anything, but it looks bad. If your stuff is down, it reflects badly on the data set, the value of the data set goes down, and also, yeah, for the organization, it's much better if all the RDF browsers are still up. But the question is, what do you do? Do you invest all the time and money, or do you risk downtime or abandon it altogether? So the goal is to have a generic RDF browser. For the people who don't know what I mean by that, there's a recent paper where they called it Puppy class, which is like an old RDF browser tool. So you put a URI in the browser or in an agent, like you use curl, and you get a representation of a resource from a knowledge graph. For example, it's HTML or is RDF serialization. And this RDF browser should be easy to use, of course, have a good design so it's accepted by the user, but it should also be lightweight, so you should put many of them on a small server that you sometimes have. Should be standalone, so it doesn't break after 5 years because it relies on some other component that goes down. And it should also be very quick to set up. You often have a new project with domain experts who don't know anything about semantic web. They want to see something. They want to have an intuition about the data. So you want to set it up quickly, configure it quickly using standards like environment variables. And of course, you want high performance. So if you have all those lightweight containers or programs in one server, it should be quick. So a common architecture is that you have an application server, be it like PHP, or you have Java with Tomcat. Inside you have the RDF browser, and then you have the central component, the Sparkle endpoint, and you have users who use the Sparkle endpoint directly for Sparkle queries, but it's also used by the RDF browser. And then you have the human and machine users which access your RDF browser. So an example which we used is LotView. It looks really good. The users love the design and the usability. But at some point our server was full, and I thought, okay, let's just buy more RAM. It's cheap, but you have to go through all the bureaucracy. And I thought, okay, this is a really good opportunity to do something new. Normally, it's not really worth it because you say, okay, the programmer time is too expensive, but this was a rare opportunity where I could do it. And yeah, this LotView looks good, but if we dive a bit deeper, for example, here into Chrome in the Network tab, we see it has a bunch of requests, like 21 in this case. And okay, you have all the static resources, you have the HTML, CSS, JavaScript, font, and so on. But the biggest problem is if you see, I don't know if I have a laser pointer here, yes. Here it says content load after 100 milliseconds. But this is a bit of a misnomer because the actual content is just loaded here, triggered by JavaScript from the server component. So here you just have the template and then you load in the data. So you may say, okay, what does it matter, 300 milliseconds, it's not a big deal. But this is just a really small knowledge base. It's just a bit over 2 megabytes of total. And it's really heavyweight, so you have 500 megabytes of RAM or more just for the LotView, and the Sparkle endpoint, okay, you can say we have it anyways, depending on if you want to have this or not. But it's a bit out of relation to this. And even if you cache it, you can see here a bunch of 3 or 4 status codes. This means you just send the header, and the server says, no, it hasn't changed, okay. You don't need to send the content again, but you still have the round trip, you still have the lag, even though some of it is in parallel. And of course, you still have the same RAM consumption of the server. So, okay, how can we make it better? Well, first, just keep the stuff that already works. Yeah? We don't have so much time. The users like LotView, it has an open license, so we just steal the design and it looks exactly the same. In fact, I just told no one for a month that I changed the program and no one noticed. And, but the architecture is totally different. So the idea is, instead of having an application server with the RDF browser in it, we flip it. And you may think, okay, that's a bit backward and stupid, but it has a few advantages. So first we have a binary compiled executable. We don't have a runtime or like some garbage collection or something like this. And we have the web framework and the RDF library inside the executable, which handles all the requests. And we have also compiled in the static resources for good measure. I mean, it won't give you much, but when you are at it optimizing, why not? So this also means you have more control over all the cache headers, cache control, the e-text. You know exactly, okay, this is a static resource, it won't change. And because WiQ loads the knowledge graph at the start, we also know, okay, this is immutable, we can just cache this as well. And at the start I thought, okay, but Sparkle endpoints can be really fast, RDF libraries are really slow, but there's a big difference. This is a logarithmic scale, so you can see in time to retrieve matching triples for some common triple patterns. It's really a big difference. And really here the red line at the bottom is Sophia, a Rust library, which is really quick. And so I used this one. And yeah, this may sound a bit like blasphemy, but you don't need Sparkle for everything. And RDF browsers are really good use case, because if you think about it, what is a resource summary? You have the direct relations, which is just a pattern with one constant and two variables, where the resource is the subject. And then you have the inverse relation, that's the object. So yeah, you don't need Sparkle. And so this is the architecture of RigView. You have the Actix Web as a web framework inside, and Sophia as a library. So let's look at it now. For the same knowledge base, we have here all the e-tags. So this is the hash for the resources, and we know, okay, it hasn't changed. We don't need to reship it. And where before you had here the 21 requests, now you have only 6 because we optimized this as well. And now you have around 100 milliseconds. It says here 140, but it loads the font at the end and it's displaying before. But even better, if it's cached, you can see before in the lot view you had all the 304s. So you go to the server and ask, oh, do you have anything new? And the server says, no, you still have the round trip. Here it's all in the browser cache. It doesn't even try to ask. So the cache headers are just set as immutable to never expire. And you may think, okay, now the problem is if I update RigView and my static resources change, I get an outdated resource, but there's a common trick nowadays. If you just attach the hash value at the end of the resource, like here, then the hash will change. And so you just have the one round trip for the HTML document itself. Of course, you can restart the RigView instance, and you cannot control the URI because that's what the user types in. So in this case, in a cached case, you have 161 bytes and 32 milliseconds on a slow server. After caching and even before, it's 140 milliseconds, it's okay. But the big thing actually is before we had over 500 megabytes of RAM and now we have 25. So if you have a bunch of those things in one server, you can really save some memory. And you can get it as a Docker image, for example. It has around 18 megabyte. So now we had handled the use case of many small knowledge bases, but someone came to me and says, okay, what if I have one really big one? And I said, okay, that's not the point of RigView, but I thought, okay, there's this thing called HDT, Header Dictionary Triples, where RDF is compressed. And the cool thing is you can still query it in compressed form. So there's the bitmap triples main component, and this allows you the really good fast queries where the subject is constant for the direct relations, and for the inverse relations you have this focused on querying extension which has an object index. So the problem was then there was no library for HDT in Rust, so we made this one as well. This was actually more work than RigView itself, but at the end we could publish it, and it was really cool to have this now. And now this shows you linked spending, which we did quite a while ago, but it was really slow and always crashed and timed out, because it had like 28 gigabytes of uncompressed RDF and triples. But with using HDT, this new setup, it's really stable, and you have like around 200 milliseconds in the non-cached case, and 14 in the cached case. You see it's a bit faster server. So okay, we don't have so much time, so thank you very much. You can try it out, for example, with Docker Compose. You can send me an issue or pull request, and I'm happy to answer questions. Yeah.
Thank you, Mr. Höfner. So we have time for one question from the audience. Does anybody have a question? Yes.
HDT is also supported by triple pattern fragments, so there are already implementations to actually get triple pattern fragments via quite sophisticated software. Did you have a look into these, or why didn't you use that?
Yes, there were the implementations in Java and C++, and we used those as a baseline for the Rust library. No.
Okay. So, thank you.
Thank you.
I will now close this session for today, for this session for tools. Also, thank you for addressing my pet peeve around semantic web and linked data, that a lot of the linked data and the web is rotting away, and a lot of tools are not functional anymore. So also very, very big thanks to providing tools that are easy to use, and let's hope that the Docker Hub is still serving them in 10 years or whatever, or you'll find another registry. So, closing words. Working with data should be fun, and tools should make it more fun, even if the data scales up. So keep that in mind, that the data will increase over a long period of time, and the tools should keep up. That's it. Thank you.
Don't forget your dots during the lunch break. Have a nice lunch, and see you after the lunch break at 1. Ah, yeah, sorry. Yes, okay. Thomas, then come here.
Yeah, I'm closing the session. That's the next session.
So before the lunch break, we have, before you can vote for the posters, we would like to have the chance to give a short introduction or advertising for the posters. So we have all the authors of the posters here that are students from the university, from HWK, University of Applied Science in Leipzig. Probably I'd like to ask you to come in front, at least one of each poster, for giving a short introduction then. Meanwhile, you're coming in front, I just want to give some information about the HWK, die Hochschule Technik, Wirtschaft und Kultur in German. So maybe my presentation will be a little bit a mixture between German and English. So everybody's living in Leipzig knows the HWK. The main campus is in Leipzig-Konnewitz at Karl-Liebknecht-Straße. We have around or about 6,500 students, and we are organized in 6 faculties. One, like the faculty where we are from, is the Faculty of Science, Computer Science and Media, with 1,800 students. We are also the biggest one in the numbers of students, but of course, like civil engineering or the Faculty of Engineers, we have a lot of more laboratory labs as computer science students are. We can satisfy with computing technology. It's more easier, so probably we are not so many in size of the buildings. Our faculty itself, it is not only computer science courses we are teaching, we have a lot of other courses. Just to give an overview, it's starting from library and science to technology, like media technologies. Probably you recognize the students here doing the streaming for the conference. They are also from our faculty, the HWK streaming team, and also the company doing the framing recording here is a startup from HWK in the field of communication technology. And we have also at the faculty like printing courses up to museology is also more regarding to the humanities. And in the center we have the computer science. We have 2 courses, or actually we have 4 courses, 2 bachelor courses and 2 master courses in computer science and in media informatics. So now a few words to the course or to the module we will be presenting here, the poster. So you can come here for the minutes to save time. You can just come here and probably can also use the mobile microphone for the students, that we can easily then switch from one poster to the other one.
Who goes first?
You should know the order.
No? You have an order, so okay, maybe you can.
Then we have to check, make it more agile. Just a few words to the course. Now that's a module in the bachelor course, and it's provided for both computer science and media informatics in the 5th semester, so quite advanced students in the bachelor degree. And in the course, we are starting with the general introduction to the semantic web technology. We are focusing on the linked data lifecycle. So data extraction, we are crawling data from the web, or we're using existing knowledge bases or linked data endpoints. And then we proceed the data. We try to interlink them, and the interlinked data set should be integrated in some web tool to get some visualization of the data. Currently we are 25 students participating in the course, and now I think it's the point where we can start with the minutes. I will also measure the time, 1 minute each team. And probably we need 1 second to find out who's the first one and the second one. Let's start now. So you can also use this microphone, but you can have a look here.
It's working? Hi, do you hear me? Okay. So the project is, we called it Museum Bibliomap. So we gather information about museums in Leipzig and also the libraries in Leipzig. And we filtered them together. And we gather also information from LVB, the transportation company in Leipzig. And at the end, we had the information of all the museums and the libraries in Leipzig with the transportation available there. So, for example, the first museum, we can see that the first museum has 3 transportation that goes to the bus number 60, I think, because I cannot see that good, and the Straßenbahn number 9, I think. So that was it.
Thank you. So you can also have a look here if you want to see the picture.
Yeah.
Do you need a microphone, or do you want us in front?
Yeah, I think so. Thank you. Our project is called the Bookfinder. It uses the famous framework from Java RDF4J for making some Sparkle queries on the internet on some endpoints that we can choose. And the purpose of that project is to find these properties of these books, and we can store these properties or filter them to use them in another queries, then to find the information about the author of the book, for example, later, or the publisher of the book. Yeah, that's about the project. But in the project, we focused also on the framework at the F4J, which makes it really easy to use Sparkle queries in a project. Thank you.
So I'm Jonas, and I am building with Alex Stepanov's model of the stock market. For this purpose, we're using the Y-Finance Python library and the Levi Tech API and the Advantage API. We're focusing on the fundamentals of the companies, and in the future we are also planning on adding some chart data and also optimizing it for machine learning.
Hello, we made a map for seeing which streets are named after certain authors or after authors in general. So we used the open data of the city of Leipzig to find out which streets were named after persons, and looked up which of these persons wrote books and made them visible on a map. So we used authority files of the German library for this and linked them with the titles of the authors. Yes.
Okay, for my project I made a visualization of a map of our city with the different districts, and we have different data sources gathered from the Open Data Leipzig website, where we can see, for example, here the total population for each district visualized in a map, and that's pretty much it.
Hello everyone, my name is Pavel Bogapov. My colleagues are Abdel Filali and Christian Kovac. And today we are presenting our project, an interactive map of Leipzig that shows crimes in each area and highlights safe zones. We collect data from Leipzig Open Data and use OpenStreetMap for visualization. Our map allows users to filter by year or crime type, giving them insights into crime patterns. I hope it is user-friendly and visually appealing. Thank you for your attention.
Hello, our project is also about the streets of Leipzig. We want to give some information about the history of the street and which sightseeing you can do, which sightseeing attraction you can do in the street. We use different data sources, also Open Data Leipzig, Leipzig Info, and Wikipedia. We focus on tourists and also on the people who live in Leipzig. That's it. Thank you.
Sure. Hello everyone, I'm Lukas. If you think about trains and public transport, you may think about delays. So me too. I decided to think about delays of public transport and use open data from the LVB, so the public transport provider, and Deutsche Bahn to get a timetable and real-time data to map and can show these data on a map with stops, for example, and the vehicles. Yes, thank you.
Hi, I'm Philip, and we did realize while brainstorming for a project that as a cannabis patient you face a lot of troubles when trying to get your prescribed medicine, not only in front of the law. That's why we decided to crawl cannabis pharmacies and
order the data in a web application, and you can filter there by strain, active ingredients, and also availability and pricing to make your life easier as a cannabis patient. Thank you.
So, hello everyone, I'm Nivet. So with our project, we want to visualize the population data of each city in Germany, and we want to visualize it for different year. And our main data, we are getting it from Genesis, the database, and we also want to implement a filter, so we can filter the data with different categories, and also we want to show the data of each city on our web application. So that's a quick description about our project. And also, since it's the last poster, I want to also thank our professor for helping us all with our project, and yeah, thank you for that.
So, and at least maybe the 10th times I want to advertise the poster voting. So you found this 2 dots on your ticket, and it's really important. The red one is for the best design poster, and the green one is the one for the best semantic web poster. And we will have in the closing session also the award session, and both prizes are donated with €100. So it's a good opportunity to get something out of the work for the classes here. Thank you very much for listening, the students. Thank you much for your work you did so far for the posters. And I think, should I propose the lunch break, or Nathanael, it's your part.
You know my words already. So we will meet at 1 here again. Actually, the lunch break will start at 12. The students were quite quick. Yeah, maybe you have some more time to visit the posters and have some cake before the lunch. I see you here at 1.
please come in. Maybe last one closes the door, and then we can start. So, heartily welcome to our session on semantic web applications and use cases. In this session we have 6 speakers from companies, partners, some projects that will present how they apply knowledge graphs in their applications and use cases. First of all, I welcome Richard Nagelmaker. So he's consulting in as a data architect or data chief for companies, and he will present us a use case on police intelligence teams and how to define context.
Thank you. So, if there is one takeaway I want to give you for this presentation, well, it's this one. Context cannot be defined up front. And the police people, they know all about this. So, I'm Richard Nagelmaker. I'm data chief and founder of UBinder. And I would like to thank you all for being here. And a special thanks to Stefan Reinhardt and Christian Brockman for inviting us to give this presentation. So thank you. Let's start with this presentation. And I forgot the name of. Oh no! Oops! I forgot. So it happens to us all the times, and Well, so the presentation is about police intelligence teams, and they want and they are continuously confronted with applications that are not adjustable to their situation, because nobody thought up front what the data should be like, or basically it's impossible to know up front what the data of a crime scene should be like. So, that's what this presentation is about, and I'll take you through this today in 3 steps. The first one is a personal experience. The second one is about a police officer from Leipzig Police. And the third one is actually one for you as well. So that's where the envelope comes in, but leave it for now, and I'll come back to you later. So, a long time ago, at my wedding day, I forgot something really, really important, and it was not the rings. What do you think? Yeah, I actually forgot my passport, because I thought with my driver's license and my credit card, I could rent a car, but I could not. I required a passport. So it took me another hour on this already busy day. We were 5 minutes late on our own wedding. I know how it works with unexpected events on busy schedules. So don't know if anybody relates, but I do now. So what I want to say here is that you really don't know what you don't know, and it can always pop up. And it's up until now, current information systems aren't able to deal with this, but that's until now. So this was my one, and my personal one, and now about this police officer. Imagine, it's an imaginative thing. So imagine 2 weeks ago, right here on the square next to this Rathaus, there was this amazing, this huge crime scene. Everybody in the city was talking about it, and they were, the news was on it, and you know what it was about? It was about a possibly stolen. Sorry, I've got this device in my mouth, but it's not really. It makes speaking a bit difficult sometimes. Back to the thing. We do the thing.
The bike was stolen, right?
Yeah. So what was this crime scene about? About a possibly stolen bike. So. Investigator Thomas from Leipzig headquarters, he came to the scene, and me and Judith were there to look at how he went, and so what he came across. So he went to the crime scene, removed some journalists, and finally he could look around, and he saw the track, and looked at it, he saw something that looked like a pedal, he saw a footprint. So he took his tablet out and started to add information. So first of all, there was a bike possibly missing, so he added the details, he spoke to the owner already. And then he wanted to add information of the track. So he said the track, and he looked at it and he said, okay, so he looked at the track itself, he thought, oh, okay, it's about 10 meters. And then he wanted to enter this information into the system, and the system says, no, there is no property length for track defined. So he's looking everywhere, but he cannot find it. So then he starts to call his IT officer, because he is he's really fed up with it. It's the 4th time this month already that he cannot enter the data he needs, and someone needs to do something about it. So he calls Amanda, and we don't use this phone today, we do this one, eh? So hi Amanda.
Hi Thomas, are you enjoying the weather today?
Well, I'm actually a bit frustrated, yeah, but...
Okay, but what is going on? Is there a question?
Yeah, sorry Amanda, I know it's not you, but our systems get me frustrated sometimes. But the question is, I want to add this length field to the track data. So could you solve this for me end of the week maybe?
Well, Thomas, I think we forgot to put that in.
Okay, that can happen, but when could you fix this?
Well, for the crime scene investigation, you want to add the track length, right?
Yeah.
Well, Thomas, you know how these things work. Adding a field on the screen requires a change to a form, an API, the backend system, and the database. So 4 things to correct, 4 times a 2-week sprint. I'll be on it. I'll be ready in 8 weeks.
8 weeks? Wow.
Yeah, but...
That's long.
No. You know how fast this is? I just spoke with my Dutch colleague, and she told me that these kind of changes takes about 8 months. So we're pretty fast, yes.
Okay. We'll do with that then, but...
listen, Thomas, did you ever hear of Infoplet? Have you tried it?
Info what?
Infoplet. You don't know about this?
No.
It's like a podium for your data. You can interact with all the data given and look at it from all sides. We have a demo, and it's running right now, and it contains a couple of concepts. If you want, you can give it a try.
Okay. Thank you very much. Do you send me the link?
Of course, I will send it now.
Okay, thank you. So thank you, Desiree. Okay, so this is the link I got, and this is the demo. So I'll start it here. And here you see some concept predefined, a bike,
footprint, square, track. And to show you, the data store says nil, so there is no data in the end. But let's get back to the entering the data. So first about the bike. So we have the bike, and possibly stolen. Okay, my typing is not going to plans, but I hope you forgive me. Brand Batavus. In the Netherlands, all bikes are called Batavus. At least that's how I think about it. A frame number, of course, and the owner said it has a security lock. One other thing the owner told me, and I'm just adding some detailed information here, it had a name. It's not by default basically for the bike in this case, but I can add a name, and it was called Blitz Bike. So okay, this is the bike, but now again about the track. So this is the track on square, and then a color, kind of brownish, and then again, length is missing. How come? Anybody familiar with the phrase, computer says no? Well, this is one of the ways it looks like. This is one of the ways computer says no, looks like you cannot enter the information you think is relevant. But not anymore. So there is no length predicate here, but there is an option, add properties. So I click that. I do length. And here you see it's identical to all the others. It's already written down in the database, and I can now just add the details. So this is about the track. Anybody else knows anything that could be on this crime scene that you want to describe, maybe? Okay. Well, I thought about a scratch, for instance. So there was okay. Oh, okay. So there was a scratch on the pavement. So this is just a new concept on pavement. And, well, length, color, length 10 meters, or no, 50 centimeters something, color white. So if you think about this, this seems maybe like pretty simple steps, but in essence, so Thomas, using this tool, can write everything, can define the whole world. So in this way, he is able to describe the scene and bring the details into the organization, so the organization learns from it as well, and can take actions on its decisions on these details. So, this was the situation with Thomas and Amanda. And now the third step is actually, I want to, I've got 1 minute. Okay, so very quickly, guys. Take your envelope. There's an envelope in front of you. And so, what do you think is inside, you know? What do you think is inside? And you can look it from the left, right? Okay, we are about to leave, so you can open it. And you can put your thought on the card, bring it to our desk, which is on halfway on the left side here. And the best idea, we get 4 hours of free consultancy. I have to go now. Thank you very much. And yeah, we hope to see you soon. Bye-bye.
Hello, good. Are there any questions from the audience?
Hello.
Hello.
isn't it like we would get many key value pairs and also many different keys that we maybe can't cluster in the end if everybody puts something else for a key?
Yeah, true. And by the way, this is triple-based, so okay. Thank you for your question. The platform itself is triple-based, so it has an additional level of objectivity. Well, how do you call it? But the point is still valid. If everybody is entering data, don't you get too many, how do you call it? Too many opinions on the same thing. So this is why around this screen there is a little process before which defines the concepts you saw on the right-hand side, you know, the bike and those things. And there is a process afterwards where people relate this data to the vocabulary, and then they can say, okay, this seems relevant for the future, so they can add it to the vocabulary. They can also say, okay, this is not relevant for the vocabulary, or this is something we usually define in a different way, and then they can change the property in that way. So that's what this is about. Thank you.
Thank you.
More questions. Okay.
No,
okay.
Okay, so my question was when you go at a crime scene with the tool and get all of the properties to describe the scene, is it in a way collaborative that multiple people can work with the same system and have the same view on the description, or is it just like local, or is it one server it's synchronized to?
Yeah, as an officer, you can send on this data to colleagues you know. Also, if you want, you can request your superior to look with you and to give you tips and advice. But that's done through phone, of course. But yeah, you can share the data with a superior, or you can share data actively with a colleague and ask him to look into it.
Okay, thanks.
Okay, you're welcome.
So, next speaker is Dr. Andreas Wilde from Fraunhofer Institute for Integrated Circuits in Dresden.
Yeah.
And he will show us or explain us how they are using semantic web technology for measuring, automating, and improving the energy performance of buildings. So that's also somehow related to what we saw yesterday, or what we heard yesterday from the people from Leipzig, that were they collecting data about cities and their environmental impacts. It's the stage.
Yeah, thank you very much. Before I start, I would like to give thanks to my colleague Hervé Prevot, who is the real expert on semantic web technologies, which I am not, unfortunately. I'm only talking about it, but he really knows what I'm talking about. So thank you, Hervé. Okay, so why should we want to use semantic web technologies for energy efficiency? Well, there is two main challenges for future building automation, and one of these is reduce wasting energy. So nowadays it's more or less like that we have three sectors, one of which is buildings, the other one is transport, and the third one is production, and each of the sectors consumes about 30% of the energy that is used worldwide. And looking at buildings, we have today an amount of 10 to 30%, depending on the building, 10 to 30% of energy which is wasted solely due to bad operations. So the building is as it is, and it works as it's more or less as expected, but you do simply stupid things. For example, you do not turn off systems which are unused, probably during night or during weekends or holidays or whatever. You could switch them off, but they are actually not switched off. So obviously this is a waste of energy. Another common reason is that heat recovery is not operated at full potential. So the automation is simply weakly programmed. And another reason might be that you have unnoticed technical failures. So stuck dampers, for example, is one of these reasons, or temperature sensors out of calibration. So things like that. And all of these things have one thing in common. The challenge is here to detect the problem. The solution, once you detected the problem, is usually simple. So it might be as simple as switching off a system. So that's not too much of a problem. But the real thing is to detect it. The other future challenge will be the management of building energy systems. So future building energy systems will have more components and quite complicated interactions. So this is simply due to the fact that we will use renewable energies, and the supply of renewable energies is volatile. So we have seasonal, we have daily, and we have weather variability. And for example, this has a strong impact on solar radiation, obviously. And so solar energy, solar electric current is not available during nighttime. Well, that's simple. So what we need to have in future energy systems in buildings is, for example, different sources, for example, heat pumps, peak power devices, or combined heat and power systems. And also, we will have storage, such as batteries or heat buffers or things like that. And the additional challenge now is to operate all these different components in the optimum way that is suitable with the supply that you get from the network, and also make optimum use of your local storage in order not to waste energy and to use it as good as possible. And the common answer to these challenges is obviously automation. This is a lot of work which is not be done today. That's why the buildings are so inefficient to some extent. And it should be done in future, and it can only be done using automation. And the common problem with that is interoperability. So usually in buildings we have lots of different systems from different vendors, and they tend to be not interoperable, and we need them to be interoperable in order to get a system optimum and not only a local optimum. Okay, so what we have to do for this? So there are lots of automation systems out there which we can use, but they are usually not used, and the reason is the following. Usually we have a description of the building, or we need a description of the building, and then we need some expert who knows what could be implemented as monitoring tasks or optimization tasks on this particular building, because each building is unique and it might have some components which are suitable for some optimization and others not. And so this expert has to decide which of these measures should be taken and which should not be taken. And this is quite a big effort. Think of, for example, Airport Munich. They have 250,000 time series there to observe, and 250,000 time series to describe and to know the semantics of, and so on and so forth. And so this is a big effort which is mostly not undertaken. Okay, so why do we need semantic web for that? Just one motivation here. In this case, I'm talking about three different types of knowledge. One is static and common knowledge, so that's concepts that you usually find in ontologies. So there are buildings which have rooms and which might have a window and so on. So that's all known to you. We obviously also have individual knowledge. So for example, we have one particular room in our institute, which turns out to be my office. And then also, which is not given here, but we have common knowledge. For example, it's a bad idea that in the winter time you open the window and keep the heating running. because it doesn't make sense. All the heat will go out of the window. So that's a waste of energy. So don't do that. Okay, and finally, in this case here, we have in the bottom line the knowledge about the current state of the building. So it's cold outside in this case, and the heating is turned on, obviously, and also the windows open. So, Andreas Wilde, your office is not operated correctly. That's what we can infer directly and automatically from this knowledge graph here, and that's what we should do, which is not done at the moment. Okay, so the architecture of the system would generally look more or less like this. We have some building, which is described by metadata, which is described by the measurement data, and then we have expert knowledge, which and also a task library, which is then used to automatically generate monitoring functions, which then can control this building here. Okay, we would like to do this all using ontologies and so on. Now, one interesting thing is about interoperability. So all of these things are very individual, and even the tasks that I want to perform are individual. So there are different views on the system that I have, and so some monitoring tasks might involve information on a very low level of abstraction, while others might need information from a very high level of abstraction. And so the thing is, how can we deal with that? So the current solution to this is that you define ontologies which describe somehow the building system, and then automatically program automation solutions to perform the tasks using templates. And now the problem is that different tasks require different levels of detail, obviously, and the possible solution would be coming to these ontologies, standardize somehow the levels of abstraction or the level of detail. And this is a quite, well, I'd say a nightmare, because this is what vendors in many cases don't want to do. And this is always something, setting up standard is a very complicated thing. And so one thing that we propose to do is first define the ontologies describing the building systems, and then in the next step also formally define the tasks and the necessary knowledge, so the ontologies that we use, in order to automatically then get the solutions, the monitoring functions by logic reasoning. So in this case, we can automatically derive these functions, and we can automatically use the right description, the right level of detail there. So at least that's the hope. And my question would be to you, if you think this is feasible and if this would make sense, if this is done potentially in other applications. Okay, so what we finally do is setting up a system of ontologies. So we have in blue color here standard external ontologies which are defined somewhere else, and then in green we have further ontologies, one of which is the so-called sense ontology, which imports the risk ontology, and I would briefly tell you what's about this thing. So in the risk ontology there is exactly all this knowledge given that how to operate a building suitable. So, for example, looking at the first rule, it says if you have an air handling unit, and the air handling unit, what that is defined in the brick ontology. And if this thing is equipped with a heating coil, so to heat the air that goes through this thing, and also equipped with a cooling coil to cool the air, then this part obviously has the risk that the air might be first heated and then immediately after that being cooled down again. So this is obviously a waste of energy. Instead of doing this, you could do nothing and the result would be the same, except a waste of energy. And so this way the risks are for energy wasting are defined, and so this is a formal description of the problem that we have, and following this formal description we can also automatically derive a monitoring function which will then monitor this thing. Okay. One thing that I would like to mention in this at this point is that this is all very fine and works good, but one problem obviously is to get the description of the building in a formal way, so to populate all the ontologies that we need. And there might this is quite an issue today in many cases, and this is what some kind of showstopper for this technology or for scaling up this technology today. And this is something where all the modern large language models and all this actual AI stuff comes in. Okay. Let me conclude with one example. So this is one building where we did all this, implemented all this. So you see a building model, and we have done manually set up formal description, so ontology describing this building and all the energy systems inside this. And from this, we can, in this case here, set up a recommendation system for the user, which gives recommendations according to the actual situation. So, for example, if the sun's shining, you can use the blinds in order not to heat up the room too much, or things like that. Okay, so concluding, we want an ontology system to automate the setup and the deployment of building management systems. And this thing relies on expert knowledge, which is a one-time effort to formulate, and initial building information, and then the system can be configured automatically. The model-based approach here is to add flexibility and also to save a lot of work, obviously, because it's automated. Now, the interesting thing for me is that the formal description of the application, so of the task or the purpose of the ontology finally, is also given in order not to avoid the standardization need for the ontology. And finally, industrial applications obviously are support for the building management, system designer or facility managers and building users, and deploying energy assistance system, or we could use it as a data structure for digital twins. Digital twins in this case using a lot of different digital twins for one building, depending on what purpose we have and what we want to optimize. Okay, so thank you very much for your attention, and again, thanks to RW.
Yeah, thank you for the presentation. There's a question.
Just for information, how many rules does the final ontology for the building you mentioned in the use case has, and what's the inference cycle, and which tool do you use for inferencing?
That's quite different depending, the inference cycle is very strongly depending on the rule effectively. So there might be an almost infinite number of rules. It's just depending on the ideas that the building manager has. And in this case, the idea is that most of these rules are usually general knowledge. So, for example, there is an organization in America called APAR. I'm not quite sure what it's about air handling and operation of these air handling units. And they have 22 rules which define common risks or common energy efficiency risks associated with air handling units. But obviously, inside a building, there are many more risks. So think of several hundreds or even thousands of rules which might be possible, but which might not be applicable in each building, depending on the
and the project you mentioned, the building you have modeled?
Pardon?
You mentioned a project where you have built your own rules for a particular building.
I think in this case it was a few dozen rules. Something like this.
And the engine, the inference engine?
Oh, that would be a question to Hervé, I'm afraid. I'm sorry for that. But in fact, it's based on a triple store, and one thing, the evaluation time. So this might be once a day, it might be once an hour or something like that, or maybe even more frequently, but usually not more than once a minute.
Okay. If there's no other question, then I thank you for the presentation.
Thank you.
And our next speaker is Diana Harner. Just my notes. She's founder and CEO of RPE Solutions from Florida.
No, from the United States, Texas.
Okay, from Texas. And she will present us a potential use case for inventory management, so for actually, yeah, supply chain management use case.
So, okay, where are we at? It's a good afternoon, morning, afternoon, I wasn't sure. So, my name is Deanna Harner. I have 26 years in supply chain inventory management. My last role in an industry role with chief analytics. Louder? Louder? Is that better?
You can also walk around and take.
Thank you. I like to walk around. Okay. So my last role was a chief analytics and automation officer for a manufacturing company. Recently went into consulting because I wanted to deliver solutions that were quick and easy and drove results. So Andre is my business partner, and I will let her introduce herself.
Hello. Good morning, good afternoon to all of you. I am Andrea van der Laat. My background is in engineering. I'm an industrial engineering, just completed a master's in supply chain. Very glad to be here. I'm from Costa Rica, and I'm currently living in Barcelona, Spain.
So like we mentioned, we wanted to develop solutions that were easy to implement, and we could implement, the business could continue on with it, and we could leave. We didn't want to be consultants that came in for 6 years and never left an organization. Our first pilot that we created is with Exensa, data semantics team. So Chris and his team have partnered with us to create a pilot program, a pre-built module, basically that's already built in 30 days. A company can start using it to reduce their working capital inventory, which affects the bottom line of the P&L. So it has basically been built at a high level on our 26 years of experience in industry doing this work, and then using data semantics on the back end to make sure that the data coming in is actually good, right? Because that's kind of important. So we'll go over a little bit about ourselves and data semantics. We are not the technical presentation today, but we do have people who are technical with Exensa if there's questions we can't answer. So like we mentioned, our business partner is Exensa. They have years of experience in data semantics. Chris and I have known each other for over 5 years, and we're very excited to partner with them to develop this solution. So the journey to knowledge-centric for most companies. So a lot of companies are in one of these three, or maybe depending on the business unit, they're in all three, potentially. So the very first one is kind of the app-centric, ERP-centric. A lot of the technology and so forth is written into the interface code. So if you want to know knowledge or information about how the rules are done, you have to go into the interface code. The second area is data-centric, and so as you can see in that area, it's really in the brain of the developer, right? So the developer is the one who's writing the code, taking the information to make the data work, and so that information is in their head, and it's not accessible to everyone. Now, you can't access them if you can get the developer to sit down and talk to you, but it is in their head and it's not accessible across the organization. Knowledge-centric, the reason that we love it and we wanted to partner with Extensa for data semantics is in knowledge, it's accessible, it's scalable. You're basically taking the information out of everyone's head and out of the process and the systems and the tools, and you're putting it into a space that everyone in every system can use to drive results for the business.
Now, focusing on this third approach, knowledge-centric, we're going to talk about data semantics simplified. So what are some of the benefits of documenting enterprise knowledge? And we are going to talk about it because we want everyone to be aware and aligned about these benefits. First of all, it simplifies employee onboarding. It's not going to be owned by one single person. It's going to be centralized, so when there's a new person, it's going to be way more simple to all the process of onboarding. Second, it improves workplace efficiency. It reduces workplace errors. Instead of being manual, we're going to reduce a lot of human errors, potential mistakes. Fourth, unifies storage of enterprise knowledge and boosts employee engagement. There's actually Harvard Business Review research that shows that with this sharing of knowledge and this centralization of knowledge, people, teams, and organizations are more creative, more innovative, and also have better performance. So going to improving efficiency, there is McKinsey research that shows some surprising numbers. There's 20% of the time of people at work that is spent in looking for information. So if we translate into a whole week, this is going to be 8 hours. So 1 day out of every week, we look for information. Then talking about reducing errors, here's how this reduces errors. Before the data being published, it is first validated, it is first approved. So now we're going to guarantee that employees will have error-free data and error-free knowledge to make their decisions. And here, lastly, we have hypothetical example. We're going to meet our knowledge owner and bottleneck. We're going to call him John. So John is an SME and data owner for a project that we want to develop. So I'm going to be the developer, and I have to meet with John. So since he owns this data and this knowledge, and no one else knows it, I have to meet with John, not once, not twice, but several times per day and per week, which then translates into more than 100 hours of both of our time, so that he can share all his knowledge with me so that I can develop this module, planner tool module. So what happens, it is completed successfully, but then we want to build another one. They want to build a module in inventory. So now the developer for this one has to meet with them again, invest more than 100 hours again, and it is duplicating time, efforts, and resources for all of us. So the first benefit of implementing this is avoiding this to happen. Second, let's say I decide to leave the company for any reason, and now I have to train a new developer to take the module that I made. So this is, again, let's say 40 hours of training for the new developer. He's going to have to, or she's going to have to invest a lot of their time to understand what I did. And again, duplicating time. And finally, we want to have in the companies, of course, people who are actually adding value, because they are adding value, not because they own the data or own the knowledge. So what's the third benefit of implementing this? If we have centralized knowledge and centralized data, no one's going to be the owner of this. So we can guarantee that people is going to be in the company because they actually add value and make decisions and invest their time in adding value, and not because they own the data and no one else knows it. Oh, and then besides this, we have BI. So what are the benefits of implementing BI and having a BI front in our companies? It's going to be labor productivity and fact-based decision-making. So 3 benefits we have on this are specifically increasing analyst work time on value-added activities, as I was saying. If we have a BI front and we provide these BI tools to the people that are making decisions, they're going to invest their time not in modifying data, transforming data in Excel all day, but having this data already transformed and making decisions with it. Secondly, we are going to guarantee improving efficiency and reducing errors. since it's not going to be manual, it's going to be centralized, automated, etc., we're going to have less risk of having these manual errors. And third, improving fact-based decision-making. We're not going to be doubting which is the right source for this, is this ERP or this other ERP. No, we're going to have it already centralized, so we can guarantee that it's fact-based decision-making. Finally, we have Forrester research, which shows two very interesting numbers. First of all, on labor productivity, applied in areas such as HR, finance, etc., we can have $14 million in the first 3 years of savings. And then fact-based decision-making, by having this, we can have $3 million savings in the first 3 years, so very amazing.
So with all of that, we decided to do a pre-built tool that can be launched within 30 days, focused on inventory, which hits the bottom line of a P&L. So basically, this pre-built inventory solution uses data semantics. It uses BI interface and visualization so that leaders can look at it, start making decisions, and action is taken. The benefits of pre-building is we don't have a 6-month assessment to try and figure out what we're doing. We have it done and ready. We'll spend a couple of weeks with the client to make sure we understand their business and talk to their Johns of the world so we can get the information from them. We also are able to partner with clients because we have supply chain experience, and so we can understand quickly how it works because we have expertise in that area. The value proposition of a pre-built, we believe, our solution, we know we can implement it in a month. It adds value instantaneously versus other options. So we know that we can go 6 months faster than other solutions that usually take a 6-month assessment before they begin build. The pre-build keeps assessment and launch costs low, as well as we can add other focus items. So the inventory is the first one, and the reason we started with inventory is because a lot of companies, at least in the United States right now, are in recession, and so money is tight, and they're not spending a lot. But if you can reduce expense at the bottom line, the CFO is much more interested in discussing it with you, and then at that point we can do sourcing, logistics, and other areas of supply chain, finance, IT, and continue to build across the enterprise. So we're going to go over just some high level of some of the visuals that are already built, and this is the supply chain piece. This is the front end that the leaders will get. You can't see all the details, but it's based on visuals that will immediately have actions that the leaders can take.
So the first module of the 3 is Inventory Executive Overview. This is a high-level view that is going to show the main KPIs in inventory. And it's going to be broken down by inventory type, category, dollars, quantity. The second module is Inventory Rationalization. This one is basically going to rationalize items and tell us which ones we should keep in our inventory, what's their ideal safety stock, and it's going to give us a detailed page and a detailed view recommending actions to the SMEs. The third module is Inventory Standardization. This one will show us which items that are the same or likely the same we can take out of our inventory portfolio without impacting the customer. So finally, we have high-level requirements to develop the pilot. First of all, we will need from the company the reports directly from the ERPs, not transformed. The reason is because for the pilot, we are going to use direct reports and not connect to the ERPs yet. Then we will have business SMEs interviews to get all the special refines that we have to do or special transformations that we have to do to the data specifically for that company. And finally, we have 30 days to develop the pilot. So after 30 days, we go from this downloading the report to this implementation of the action plan and reducing working capital with the pilot. After the pilot, we will work with the organization to connect directly to the ERPs and get Extensa software to act as well.
So based on my experience working across Fortune 500 companies, this easily is a 10% reduction in inventory. It can be more or less depending on the complexity of the organization and how far we go into the business. Do we set one business unit, one site? Do we go across the enterprise? Is it international, domestic, and so forth? So that's what we've seen in industry, and we're very excited with data semantics on the back end to be able to make it even more powerful. Basically, if you scan the QR code, you can get our website contact information and also time to schedule with us to hear more about the pre-built solution and how we believe that data semantics can drive real-world examples in business and drive results to the bottom line. Thank you.
If not, then maybe we continue with the next speaker.
Awesome. Thank you very much. Appreciate your time.
Our next speaker is Sebastian Hellmann from Infi. So you're from the Institute in Leipzig. And he will present us the DBpedia Databus, a ecosystem for managing or accessing data sets and finding them via their metadata.
Okay, yeah, thank you, Magnus. Yes, I'm going to talk specifically about the Databus 2.1.0 release, which is the first public release of the Databus. Before that, we had internal beta phase, internal versioning, and 2.1.0 is like the first publicly available release. Right, so there's a link to the slides here. Also, the GitHub link is very important because that is the main access at the moment, and also the email to the Databus management team. I'm going to give a very brief overview of the DBpedia Databus platform, and then I will present two use cases or use case areas, basically, of the Databus. So one is building collaborative data spaces. A very important point, because this really has the potential to unlock the exponential power of open data. Yeah. The other one is deploying the Databus in an enterprise context. It is really a data engineering tool, so it shouldn't be seen as, oh, this is only for open data, but we have closed data, it doesn't work. No, it is about data engineering, a tool for data engineering, so it can cater to both worlds. So in a nutshell, what does the Databus do? The Databus is a virtual bus system, which means that you have data sources or data storage at the bottom, depicted as the database cylinders here. And for each of those, you get metadata and a download link. So the download link is basically the link where you can download the data. And then you push it all into this metadata knowledge graph. And from there, users can search over it, query it with Sparkle, and also get the download link and download the data. So it's like a mediator platform, yeah, between data users and consumers and data or storage, let's call it storage, URL enabled storage where you can download the data. So let's talk about one of the projects where we deployed the Databus, yeah. So this is about building collaborative open data spaces. There is the DBpedia knowledge graph. Many of you know it, yeah. It is published since 2008, so we are now in the 15th year of existence for the DBpedia knowledge graph, the data set and the Sparkle endpoint. And around DBpedia, there is an extremely productive community. Yeah. So what does this community produce? So they produce data, additional data in RDF or other formats. they produce applications. And I would also claim that almost all semantic web applications that were created in the last 15 years have at some point been benchmarked with DBpedia data, yeah, because it was so available and people wanted to test out their tool and then they used DBpedia. And they also produce publications. Now, what are the challenges here? So we put the data online, everybody can download it, fine. There's a large community, but how do you get in contact with the community? So there is a big gap between the people putting data online and then a lot of anonymous consumers that produce very awesome tools and papers and applications and derive data with it, yeah? What you want to do is, you want to have cross-fertilization of innovation. That means you want to have all these people that work with your data work together, yeah? So they produce ideas, they implement ideas, the next person from the community can use it immediately and build upon it, and that does kind of like spiral up this innovation, yeah? So this is an agility aspect, yeah? That things are available in a timely manner and people can build on it again and drive innovation this way. Therefore, you need something like upstream commits. So it's not a publisher-centric platform where one party publishes something and then doesn't know who uses the data, but you want the community to get active. So you want to capture improvements and you want to capture extensions. The other thing is also, which is also important, you want to analyze data demand. So this data is there now, and then people need to tell you in some way what data they're using and what data they want. So you can kind of like adjust the project, or maybe somebody from the community can also fill this need for data, yeah? So there's a lot of matchmaking between the provider and the community and a lot of potential as well. So we have databus.dbpedia.org. This is where we deployed the databus since 2018. So this is an eat-your-own dog food development, right? So we had a beta phase of 5 years, basically, until this first release now, the first public release. And the mode we did it here is that we have a community, and this community builds around the main data set, yeah? So we publish the data set, and the community uses this data set to build more things around it. So the DBpedia knowledge graph is quite big, yeah? 15 billion statements and 5,000 files each month, yeah? So this is the throughput, basically, what we put on the data bus each month. And then every 3 months, we take this data and make a validated and consistent snapshot release also on the data bus. So what are the key facts here, yeah? So after 5 years now, we have 3.6 terabyte of data reachable, and users do around 200,000 requests per day. In total, there are 350,000 different files, so this is download URLs, and these span over 30 different domains. So that means we have integrated 30 different storage spaces, yeah? Most of them are Apache web servers under different domains, yeah, different servers. But there's also links to GitHub, links to other places as well. Yeah, anything that has a download URL. So what does the community build here, yeah, on top of this? There are starting to be Dockerized applications. That means because this metadata structure is very well structured, you can define data dependencies that go into Dockerized applications which are ready to deploy. And that is a good transfer between the community, because one party can write a tool, the others can use it immediately, modify it, republish the data, or derive the data, do anything with it. Yeah, so there's an agility aspect in applications here. We have upstream contributions, so we have 30 community members that publish their data extensions next to our data set on the same platform. Yeah? And we can analyze data demand because the users built 250 collections. And collections here are user-created data catalogs. I'm sure many of you know DCAT, and DCAT has a very publisher-centric view in the sense that the person who provides the data should also make a catalog. Yeah? And we have the data bus has the philosophy that users need the data, they select the data they need, and if this is useful for one user, it might be useful for another user as well. Yeah. So I'm going to showcase this here. So let me show the front page of the DBpedia data bus. It's a very functional tool. Yes, at the moment we are crawling all ontologies and putting them on there. There are quite a few, as I said, there's quite a few data sets you can search on it. Now let's look at the collection. So this is a collection that is also published via DBpedia. So it's a catalog of data published by DBpedia. You can see it has 86 files, a total of 4 gigabytes. So this is the monthly snapshot. Yeah, if you go, there's some documentation attached to it, and if you can go down here, you can see all the files that are in this collection. Yeah, so they come from different artifacts. If you know Maven, you will know what artifacts are and versions, and so there's the structure to it. You can also export a list of download URLs, so you can automate the download. Yeah, wget or curl is the easiest. There's also a databus client. And the underlying mechanism of this collection are actually SPARQL queries. And I'm going to show you this now because they're very long. Yeah, these potentially very long SPARQL queries, but they are just unions. Yeah, so each block basically selects one part of the one specific artifact, yeah, and version of this. So this is always querying the latest version of a certain artifact. Yeah, so the queries can get quite long. Yeah, the SPARQL store can handle it, so that's fine. It looks a bit like overkill, yeah, but the good thing is that you can actually, and this is also what the users do. Wait. Yeah, so you need to be logged in, right? So if you don't need all 86 files, yeah, then you can go to action and you can say, edit a copy of this collection. And this imports the catalog into your own user space. So this is Kurzum, this is my user space, where you can assign a new collection identifier. So these are persistent IDs unless you change them, yeah. Where you can share the link and tell other users exactly which data you used for your applications, like a definition of data dependencies here. And then there's the, wait. This one here. Yeah, and this is where you can modify the content of the collection, yeah. So you can aggregate over several data buses, so collections, the catalogs over several data buses, and then, yeah, what you can do is you can just remove artifacts and add new artifacts, so there's a whole user interface to create these complex SPARQL queries. Yeah, then you save it, and you can use it later or share it with others. And also put it in your application as a data dependency configuration. Right, and here this provides a good sense for the community what data people are using actually from DBpedia because they built this into the collections. Another example where we also deployed the data bus is the Open Energy data bus. So this is a different kind of community. So DBpedia is a very data engineering focused community, semantic web focused. And this here is a research community in the area of energy systems. So they can code things in Python and they can work with data, but they're not semantic web experts or anything. And the mode is very different here because you have 200 researchers which contribute and reuse their research data. So there's not one main publisher providing a large data set, building a community around it, but more a decentralized network of peers and professionals contributing to the same platform. And what the databus provides here are transparency in the workflows, yeah, which is important for research and reproducibility, provenance, and also citable persistent URIs for data. Yeah? And this goes into each step of a workflow, yeah, not just the end product. Normally with research result, you only get the end product and not the way it was created. Now, if you look at a bigger picture here, So on the left side, we put a lot of examples of URL-enabled storage. So this means there are tools where you can publish data on the web, and then you can have a download URL, basically. And all these can actually be integrated in the data bus with the metadata interface. Yeah? And this means that you have several data buses, but they are uniform, and this forms a data bus network where you can query over different data buses and access different storage modalities. Yeah? So this is symbolized by the data bus. This is actually the real data bus symbol on technical laptops, for example, on the technical drawings. On the right side, you have data-driven software. So this is all software that consumes a lot of data. Yeah? Software always consumes some data, but these are the ones that consume massive data. So we put a lot of options here, but in the end, most of the data is actually, do I see the pointer? Published via Apache web servers, very simple, or Nginx. I think these are the most common ways of actually publishing data, some sort of file server. So while there's many options, I would say these two are the most popular or predominant here. But we put them here to show that this is a very generic interface that covers a lot of storage. On the other side, there's a lot of data-driven software as well. We put mainly the ones from the DBpedia members here on top. Also additional ones which are popular. But here also this Dockerization of any software, so putting data into a Docker with software will be the most popular one. We assume that, because it's a very generic one. You just Dockerize the software and then put the collection link in the Docker and say download this and load it into the software, and then the application runs. Another arrow here also shows the republishing. So any data that was analyzed here or transformed can also be republished, basically again on the file servers, and then put on the data bus again. So there's kind of like the spiral, the upward spiral. Yep. So now we'll leave the open space, and go into an enterprise context. So I'm going to talk about data bus deployment levels. So we already tackled the open space, the open communities. Data bus is not a maximal solution, but a minimal solution. So it is not like you need to go all in and commit to it very heftily from. So you can deploy it on an organization level. This would be a very high commitment actually. Implement your enterprise data strategy. So DBpedia, we committed to the data bus as an organization here. It is good. You can implement your enterprise data strategy. You can tackle pain points in data engineering, things like efficiency, automation, scalability, and data quality. More minimal, you can use it maybe just for one department, a group, or a team, and systemize the data workflows internally. Maybe if you have people a small team that needs to handle 50,000 files from different sources or so, then this would make a lot of sense to use a data bus there. You can use it in collaborative projects, where you can efficiently coordinate data with partners and customers in like multi-project environments as well. So this is across servers, and across different departments and organizations. Or you can put it in your application, product, or pipeline. So this means you streamline and automate the data flow and the data dependencies for one software, basically. Or you might have variants then. Let's say you have 100 customers. Each one wants a little bit different data into their pipeline. Then we have a lot of variant management, not over the software. So software variant management is very well researched. But the data variants. This is what the data bus can do. So let's talk about return on investment here. As I said before, so there's low investment. It's an open source tool, Apache 2 license, very compatible. Integrates also seamlessly into existing enterprise landscapes. So you can use single sign-on, like we tested it with the Siemens ID, and also the DLR ID works very well. You can use it as a semantic layer on top of things, yeah? Like we did with the Open Energy family. Yeah, they have a lot of databases. We put the semantic layer on top. You can use it just for new projects where you think we need to have complex data workflows there. Or even you can use it as a plugin. So in Essenza CMEM, we installed the data bus as a plugin, which can be installed and bundled with the corporate memory. So documentation is available. Counseling, support, and training is also available. We hold free tutorials as well, DBpedia tutorials. There are great returns. Yeah, the one thing is agile data engineering. Am I over time? Okay.
Maybe we have a question. Or is there anything?
Is it over already?
Yeah, it's you're over time already. Yes. Okay. If there is not a specific question, maybe there's one point you want to finish with. If not, then my question would be, since this is a community project, it's an open source project, how can the community actually help you with that project?
Yeah, so just use the data bus. Yeah? So we're looking for adopters now, because the real potential comes if you have a lot of data sets from different domains, and you can query over several data buses and combine the domains. Yeah, like energy with buildings, for example. We had this before. So that is the real power, that you can combine and aggregate these data sets. Yeah.
Okay. Thank you.
Okay.
Next speaker, I welcome my colleague Marcel Fröhlich. He's also from Essenza. And he will show us a use case on how to develop a product, and by doing that, go from the initial definition up to the documentation that you need in the end for the product.
Okay, thank you. So, thanks for having me. Welcome. My name is Marcel Fröhlich. I'm running projects and consultant at Essenza. And we were mentioned multiple times during the day already. And today I'm going to talk about some of the work we do with different clients. And for those who don't know, we're producing a software called Essenza Corporate Memory. It was just also mentioned by Sebastian, thank you, which is about, well, it's knowledge graph platform, very much focused on providing functionality on top of the plain data stores, which is supporting all the tasks that engineers and also people who contribute to data processes within solutions, typically in commercial environments, need to have or need as basis to build solutions for data-centric solutions in any domain, basically. So we started off, like many of these projects that we saw in the beginning, we very often had projects that focused on basically data integration, so pulling data together from multiple systems, which is always still a key ingredient of many of the projects that we do. But gradually the focus kind of shifted, because it turned out, well, putting data together is great and also required to get out of a single process and do new things that are just requiring a mix of data that's typically coming from different processes, from different departments, different domains. But the actual value then starts to show up if you provide some means to infuse this data with information and knowledge that is not present in any database. And it turns out a lot of really important information is not in databases in organizations. Organizations are always a mix of, well, the IT support systems and compressed databases that hold key master data, process data, whatnot, but a lot of subject matter expertise of all the details, sort of the common sense things, how everything binds together, how these different bits of information are actually combined to make sense and to run a process, are very much still in the heads of the people. They're encoded in organizational processes. They are not written down, well, they might be partially written down in, let's say, documentation or process documentation, but they're not necessarily readily available in databases. Very often because it's very basic, stupid stuff, where everybody thinks, oh, well, this is obvious, we don't need to write this down. And I bring an example that applies across many cases, basically in manufacturing, but also in software, which focuses on product creation, product development, starting from requirements, ending with documentation. So a key topic where we typically come into the game is when it comes to documentation production here. So we're talking about no matter what, if it's a piece of hardware, if it's a piece of software, if it's a complex system, there is always different aspects. It starts with a process about product management, so a persona is defined, a product is defined, requirements are written down, who wants to do what with the product, and this is handed over to product development, where smart engineers sit together, come up with a design, build whatever, for example, this brilliant piece of silicon with all kinds of things on it that do something. And obviously, product data is created, but the product data is very much focused on what is in there. So what are the elements that make up this product? What is the bill of material? How is it wired up? What are the interfaces? So structural knowledge altogether. But nobody takes an effort to at least systematically link all the detail requirements in some system up to all the components that finally make up the system, which makes it quite a challenge for the people that are in charge of documenting this stuff to write documentation, because usually you need just a mix of these two perspectives. So basically it's the structural knowledge, what I described being in your typical product database, versus the functional knowledge, which is about why is this there, how is this used, what is this for, what is the intention, as a user, what do I have to do, I need to press this button, what happens then. The linkage of these information is not given, and obviously that still sounds again very much like what I described in the beginning. Okay, two data sources, let's wire this up, are we good to go? No, not really, because there is still information missing. So we came up with a set of models that obviously integrates those two domains, but additionally adds information about temporal structure of what's going on there and causal structure of how things relate and what causes something else. And besides coming up with this model, the challenge that we face in rolling this actually out in production processes is to make it useful to or usable to a broad audience. So there is no point in coming up with complex machinery that a handful of engineers can work with, because ultimately there are, as I said, product managers out there, product engineers out there who know all the details and need to have some tooling that allows them to model some rules and some aspects of these relationships in a way that they don't need to learn to program or become ontologists. So the challenge is to tone this down to a level where useful modeling is still possible, but where it's simplified in a way and many things hidden that can be hidden, so that it feels simple and natural to interact with this thing. And with this input of additional model information, additional rules knowledge, allows us to build a knowledge graph that holds all the information down to a level of detail where things like automating, generating documentation structure, interacting with this information in a dialogue style is rich enough to enable that. So this is something that we're doing in more than one customer project at different levels of maturity, different focus of what needs to be done first. So is it more about the actual structural creation? Is it more about checks that we automatically generate, or sort of to-do lists that we create for some still human editors? Or is it, which is the obvious next step that is close by, given the world of language models comes up, is it to finally actually generate pieces of documentation automatically? So it's the product manager's knowledge, what is it for, the product developer's knowledge or the software developer's knowledge, to be combined in a way that it feeds into activities in the work of technical writers who describe activities of end users, and get this pulled to a platform where these type of things can be automated. So ultimately enriching models in a way that data from product databases can be interacted with, either for product documentation use cases, for chatbot use cases, or all kind of other data exploration use cases where this sort of filling the gap between all those structural things that already exist with rather small model pieces in between allows people to connect things up and automate to a level that goes beyond what we typically see today in organization, which is especially important because we already have this mass customization tendency on the manufacturing and production side, while the documentation processes themselves didn't really catch up so far. So they're facing the typical challenge. It's not really an option to start hiring 10 times as many documentation people just for the fact that the number of variants of products that clients can order increases, because they're not going to order 10 times as many things, they're just ordering different things. So this is what we did, this is what I wanted to point out. If you're interested to see how these types of models look like and what we do in detail, you're welcome to visit our booth, and then we can have a chat and look at things in more detail. Thank you.
Thank you, Marcel. Is there any question? We could have time. If not, then maybe we jump to the next speaker. We will go a little bit over time. So if you would spend 10 minutes from the break to listen to our last speaker. Our last speaker is Dr. Thorsten Liebig from the company Derivo in Ulm. They also have a booth outside here. And he will show us how to explore and query huge knowledge graphs. So that's actually a topic when customers hear knowledge graphs, they always want to see them. So the Essenza logo has 13 dots. There's a mini version which has only 3 dots. That is visualizable. But when it becomes huge, it's much more difficult, and that's why Torsten presents us SemSpect, the tool from DevRevo.
Thank you. Yeah, thank you for still showing up in such large numbers for the last talk of this session. I really appreciate that. I will talk about scalable, no-code, data-driven querying and exploring big data graphs. And the topic behind is how can we gain meaningful insight into diverse and big data graphs, how discover the structure of large graph databases in data flows without any prior idea of the data or any query language skills. Furthermore, at a scale where the beauty and simplicity of node-link diagrams, we all know, turn into clutter simply because of the large volume of nodes and links. And I will show you tooling that uses visual aggregation to build a meaningful visual query language to browse through large volumes of graphs from the meta level down to node and relationship details. Just a few words about us beforehand. We are developing semantic software tools and provide consulting on graph-based data modeling since more than 12 years now. Our customers are mainly from the engineering domain, such as Siemens, Schaeffler, or Festo, but we also have Springer Nature or Bertelsmann, for instance, as customers. The team background clearly is in knowledge representation and reasoning. And the techniques we use in our projects include data cleansing, data integration methods, data schema modeling, reasoning, and knowledge graphs, of course. And in this context, we mainly offer 2 products. One is RDF-Ox. RDF-Ox is a high-performance, in-memory RDF triple store with a very performant Sparkle query engine and a high-performance data log materialization engine. RDF-Ox is developed by Oxford Semantic Technologies. And if you're looking for a very capable and performant triple store, then RDF-Ox probably is the system of your choice. With respect to browsing, we have a Meta Explorer that is currently in alpha development, and SemSpect, a scalable graph browser, and we will see SemSpect in action just in a minute. Many companies have started to build large graphs for various purposes. The term graph here does not includes many of the data sources out there in the wild, not only labeled property graphs or RDF graphs, but also many relational data sources. Just think about a foreign key that connects 2 data objects in 2 different tables. That basically is a relationship of a graph. And the big question is how to gain insight into such data graphs compiled from many different sources, how to find the interesting patterns, but also the local specifics. And well-known graph visualization and interactive rendering are frequently mentioned as solution to this task. And I'm pretty sure that all of you have experience with such graph visualizations that render a graph as dot and lines, and very similar to what you see here on my slide. And often you can interactively, step by step, add new nodes to already visible nodes and links. That is data-driven, which is great, and it also works for small graphs, but fails even for medium-sized graphs. You often end up with a hairball, as here on my slide, caused often by a poor control over the expansion. You either see too little or too much, and I personally find it difficult to keep orientation in such graphs because of the heavy reorganization of nodes and links by the typically used force feedback algorithms. So, okay, Exactly. So let's make this a little bit more concrete, and let's assume we are prosecutors and would like to effectively analyze the Panama Papers. In this case, we could draw on the work of the ICIJ, the International Consortium of Investigative Journalists, which have received tons of data over the last years through different leaks. And there were groups of journalists all over the world that looked and researched into this data, tons of emails, bank account statements, contracts, and so on. And they extracted persons, entities, and relationships in between them. Altogether, a graph of 2 million nodes and about 3 million relationships, approximately 100 times the size of the graph of my previous slide. Let's consider we want to investigate the officers that share an address with an entity in Germany. Here we could start with the entities in Germany. Not sure. Okay, you can see the green dots here on my slide, which are the entities in Germany, some 100 probably. And from there we could go to the addresses. So these entities are related to addresses, which are the red dots here. We see that there are addresses shared by a couple of entities. And from these addresses, we would like to go to the offices that are also related to these addresses. And here it starts to get messy. We see that addresses probably are shared by many different officers, but we don't know how many and which they are without constantly zooming in and out. So to solve this problem, we have developed SemSpect. SemSpect is a graph exploration tool with a focus on scalability and data size, expressivity in querying, and a very simple user interface. SemSpect groups nodes by their type, and it allows to selectively explore these groups, and it also allows for very expressive filters. And let me briefly switch to the system to replay the example I had on the slide before. Here on the left-hand side we see all the different categories of nodes in the graph, the addresses, entities, officers, and so on. And I can just drag and drop one of these categories here in the visualization in the middle pane. Then I see, okay, there are 800,000 something entities. I can look into the details if I want. So here, oh, thank you. Let's see. If I can fix this. Okay. Yeah, better now. Okay. Here on the left-hand side, you see the categories of your graph, and I just dropped this entity category here into the middle pane, and there you see a grouping of all the nodes. Here you see the details in this tabular view here. You can click on one of these, then you see details here in the detail view on the right-hand side. And what happens when I click on this triangle button here, then I see all the other categories of nodes that are connected to these entities. So the addresses, officers, and so on. And the second level of the menu shows me the relationships that connect these two groups. So let's go ahead with the addresses to follow our running example. And then okay, let's look for the entities in Germany. So I do a filter here on the entity group on the left-hand side. There are 214 remaining, and I can apply this filter to the entity group on the left, and then you see that this group gets filtered down, and the filter also propagates through the graph here. Okay, let me set the threshold to 500 so that we can see all the entities. And here we see the concrete nodes. I can click on them. We see nodes that are light gray. These are those nodes which don't have any successor in one of the groups on the right-hand side. And we see numbers here that indicate the number of connected nodes in the left group. So there is an address in Kiel, in Germany, that is connected to 21 entities in Germany, which at least is surprising. We can highlight them, and we can go from addresses further to offices to check for our initial request. Here we have the offices. We can also save such a group as a new label and write this label back into the underlying graph system. So let me add here address of entity in Germany. And this is written back into the graph, either as a label for label property graph or as a class for RDF graphs. We see that label here in the left-hand side. And we can go ahead from offices back to addresses and then filter this group with the newly created category we have created to see which are the addresses that are so heavily connected with offices. And here we are. Here we have these objects here. Okay. Back to the presentation. Let me wrap up. The right tool depends on your use case and requirements, of course, but keep in mind that visualization is the last mile that can make your client happy or leave them dissatisfied. Key factors for visual analytics in large data graphs is that it should be data-driven, it should scalable with respect to the visualization paradigm, and it always should provide an overview and details on user request. I've showed you Zemspec. It comes in 2 versions. There's a Neo4j version. I showed you the graph app for Neo4j Desktop. Neo4j Desktop is for free, and we also have a freemium version, so you can work with your own local graph and Neo4j. We also have a server plugin for Neo4j Enterprise, and there is an RDF version coming very soon. So if you would like to serve as a volunteer, as a beta tester, just drop me an email or visit our booth to talk to each other and see what you have as a graph. Thank you.
Are there any questions? Nate.
Since you're working with property graphs in your system, and we have a huge semantic web community here working with RDF, so how do you see RDF star? Or are you familiar with RDF star?
Yeah, sure, I'm familiar with it. Most of our projects are dealing with RDF graphs. And I see RDF star as a very, very good thing, and it is a very nice piece of functionality that reduces Sparkle code in the end and makes queries more readable and better in the end. I really appreciate RDF star.
So would you say it's more an advantage for property graphs or for RDF, or you?
For RDF.
Okay. Thanks.
Any other questions? If not, then thank you again, Thorsten. And everybody can go to the coffee break. For those of you who still have a sticker on the back of their badge, please go to the posters and vote for your favorite poster. Last chance. Red is for design, green is for content.
last coffee break. I hope all of your badges are empty now and you've distributed your dots, your green and red dots. We are now here for the last session of the Leipzig Semantic Web Day. And the session is about semantic technologies and artificial intelligence. And our first speaker will be Lars Peter Meyer from the Institute for Applied Informatics. So, you know how to open them? No? No, okay.
We created a folder I, and there should be more slides. Okay.
Ach, das sind
die sind alle schon offen.
Ach, hier unten?
Okay. Ja. So, jetzt müssen wir nur kurz schauen, welcher der richtige war.
Ja.
Der hier?
Nee. Dann geben wir mal den oder den. Das. Ja.
Das.
Ja. Stage is yours.
Thanks. Hello everybody, my name is Lars Peter Meyer, I'm from Infi and I'm presenting our work here on the large language models and the use cases or possible uses for the knowledge graph engineering. Actually, I have to tell two things about this up front. This is not the work of only me, but from several colleagues of me, including Kirill, Norman, and Simon, not yet this time, okay. And this is actually just a summary of our work. For example, on Friday, the republication and the longer talk about some of the results will happen. Okay. When talking about knowledge graph engineering, normally I'm working, for example, for the project Stahl Digital, where we are helping material scientists to organize their data, how to tackle their real-world problems. But then, in the beginning of this year, end of last year, as probably everybody here knows, ChatGPT was in everywhere. I guess everybody here checked what is possible in their field, and similar, our team discussed what could ChatGPT and similar large language models could do to help with our everyday work. Maybe we can start with some question. Who of you have used ChatGPT already? Please raise your hand. Okay, that's almost everybody, as expected. Who of you is using it for programming? Most, okay. And for your work with knowledge graph engineering? Some. Okay. But yeah, it is already around the topic. Some blogs as this, but we decided maybe we should do it not just single experiments, but do it a little bit more scientific way. So we came up first with collecting a couple of use cases which came to our mind in our expert discussion rounds. So we had already this morning in the keynote the use case. You could try to get a Sparkle query from natural language with the help of large language models. You could try to explore or summarize knowledge graphs, very, very similar to the keynote example this morning. We thought maybe we could get help with our work with competency questions, because there we have many natural language questions and want to interact with the structured data in the knowledge graph and combine them and align them. Of course, code generation is programming, where most of the hands were raised. We had already this example today as well. One could populate a knowledge graph with the help of ChatGPT and large language models, and some more topics are possible as well. But collecting this use case is very, very easy, so to do it a little bit more scientific way, we designed some experiments and executed them a couple of times and gave scores to them. First experiment was we gave the ChatGPT a very, very simple task. The blue lines here is the prompt we actually handed over to ChatGPT. Like here we gave a ChatGPT turtle graph, very, very basic. I put it here on the right-hand side, no laser pointer. On the right-hand side we have the graph here with, no mouse cursor I guess. We have the graph with 2 persons, Anna and Bob. They are part of some research or marketing department and working at a company, and this Sparkle query is really, really basic. Just collect the details given in this knowledge graph, create a Sparkle query for it. And the results were quite good. Syntax were okay for all of the queries we got from the results. Okay, most of the results were okay. Some minor flaws in there. That looks very, very good. So we had, with this basic, very, very small graph, other checks we have done. For example, can you find a connection between 2 entities? Can you infer can you suggest good classes when we anonymize content here? Something like, do you understand the topic of this graph if we reduce, for example, org role? Here, with a small graph, it works quite well. Then we were a little bit more ambitious and tried a bigger example. A couple of months ago in our team we had student task sheet from the University of Göttingen with some tasks for them showing their Sparkle capabilities, and thought maybe we could copy this task and ask ChatGPT what can it do with it. One of it was take the Mondial database with some very basic geographic information, and here find the river with the most riparian states along it. And we got, again I have the relevant information of the graph in the lower right corner, and an example Sparkle query in the middle of the screen, and on first sight it looks quite good. Syntax again okay, but then we had a deeper look and found a couple of flaws. For example, here the namespace for the Mondial database, Mondial knowledge graph, was wrong. It's not mondial.o, but it ends with schema. Or the Mondial database is not using the RDFS label, quite uncommon, but is using some name property there. And in this answer, the Spark query relies on the Mondial flows through property, and again this property sounds good. Semantically, I would guess sounds good, but when looking at the remodeling on this knowledge graph, it's not flows through, because flows through connects rivers and lakes, but is located in would be the correct answer. So with this bigger art problem, we found many minor and bigger mistakes. So actually, the syntax in the table on the lower left side was okay with all of the examples given, but we never got a correct result, or actually any result. Sometimes the structure was a little bit strange. For example, unnecessary sub queries were introduced, or it used often undefined properties and classes, undefined or not correct usage of the given content, and as shown in the last line, the namespace was seldom correct. I guess one can't name it here. Again, we have more of these experiments in the longer talk on Friday. Okay. Here we have the reason for one possible reason. Most of the knowledge graphs are probably too big for the context size. Current models have context size of 2,000 tokens or 32,000 tokens or 100,000 tokens, and most of the knowledge graphs are quite bigger. Then I speak up as I have to. And probably the next experiment is, I've shown you now only experiments with ChatGPT and only 5 executions with ChatGPT 3.5 and 4. And now much more models are arising and coming up. So we are now developing a benchmark suite actually, where we can plug in different language models and plug in different evaluation tasks. For example, we have one task finding some errors in Sparkle or generate some example graphs, and then we have we will get a much bigger database to find more insights, where the knowledge graphs can get help from the large language models, and what can get improved, and what is the situation in the next, for example, half year. So, I'm open for questions.
Thank you very much, and thank you very much for paying attention to the time. So we have enough time for discussion, and I think this is a topic for many questions and discussion, because I think many people already had experience with it, and so we have the first question over here.
So, I was in thanks, first of all, thanks very much for the presentation. I think most of people are playing around with this as well. I saw also a keynote in the SWC, and Polheim also played around with this, show exactly this, some of this idiosyncrasies. Let's put like this. But I ask you the same thing that I asked to him. It seems to me that basically there are two ways to interaction. One is you use the knowledge that was absorbed already on the large language model. And the second one is you use to build agents. And it seems to me that the second way, it's more a smart way to do it, because it's basically if you update something in knowledge graph, then you have to retrain this somehow. But when you build the agent, he knows more or less already, oh, I have to go there and acquire this ontology in the knowledge graph, and then I can build this Sparkle query or something like this. So my question to you, after this long introduction, is have you played with that, or are you thinking incorporate this on your benchmark? Thank you.
I'm not sure I'm understanding your question correct. Here we are more dealing with methods of using the language models capabilities to help us with the knowledge graph engineering. So for example, add more information to a knowledge graph, help the user get the correct Spark query, find knowledge graphs or find information relevant for them, something like that.
Now, there is another way now to interact that is through agents. So you can basically, it can incorporate some tasks to be performed through the knowledge graph, to the large language model. So maybe you still haven't seen that.
Training knowledge?
No. Agents. You build agent to perform some task. But you can discuss this later. Maybe taking too much.
Okay, sorry. The question is that you show some indicators of the quality of the results, like syntax correct, I don't know, result correct, and so on. When you have different language models as a plugin, usually you get different results, like different Sparkle queries and so on. Do you have a methodological way to compare those queries and somehow compare to each other without the human intervention? Like, instead of you looking at the Sparkle query and say this is a good query, to have a systematic method of evaluating the query quality.
That's exactly the step. I will here quite short. With this table here, shown for example, we have done the evaluation manually. But later on the last slide I've shown, this is actually framework where we are doing it automatically to find a score for an answer given on a programmatic way. So here we can execute it 500 times one specific task, and then just ask the program to give a score and can look at the statistics. Because we had evaluated it for very few examples evaluated by humans, and now we are working on doing the evaluation automatically. For example, for Spark query, we have not finished it yet. This is work in progress. One can look at the results given from the Spark query when executing it and checking are the results okay. Or are all the relevant terms in the Spark query, or are something in the Spark query we would not expect. Something like that. We can count programmatically and then derive a score from that. But that's actually some work we are doing now and are open for more collaboration there.
Okay, so Alyosha, you could come here already. Your next presenter, right? And one more for a short question, or are we? I think we can also discuss this later at the Semantic Beer Garden. So thank you again, Lars Peter.
Thank you.
So now Alyosha Burchardt will present from DFKI, will ask us the question, is NLP coming to an end right now? Stage is yours.
Yeah, thank you so much. Hi, everybody. So I guess my talk is a little bit off topic or exotic, if you wish, in this context. So it's probably safe for you to lean back a little bit now and let your thoughts flow. But everybody is talking about natural language processing these days, and I've been in this field, if you wish, for 25 years now. And so let me share some fundamental insights that with you about natural language processing and how it developed in this time. When we're using language, we're always communicating, right? You cannot use language without communication. Yes, somebody writes something, somebody reads something, somebody says something, somebody hears something, right? Often enough, the transfer of information is the most important thing. So when I'm reading a Wikipedia article, it's not so interesting that there is an author behind and that I'm a reader, but it's about the information as such. But then there is language usage that's purely about communication. Right? When I tell my wife after more than 20 years, I love you, so the information content is not very high, I hope. Right? But it's communication-wise, it's absolutely important that I repeat this, if you wish, trivial information from time to time. And why does natural language communication work the way it does? Yeah, I mean, we know that we are sharing the same linguistic system, so we are using the same words, case, tense, the same way of building sentences, right? I mean, I can assume that we are sharing, but we are also sharing, of course, word knowledge, right? When I talk about thinking of a red dot on a gray triangle, I don't need to explain to you what I mean by dot or triangle. You know this concept. And when I say I'm thinking of a sunset in Egypt, the same concept will pop up in your brain that I have in mind, and I can build on top of that then the conversation that I want. So when a machine enters one part of the equation, I mean, then obviously the machine needs to have this linguistic knowledge and this word knowledge that we have to perform certain tasks and certain things. And when I started with natural language processing, like more than 20 years ago, so there was borrowed from classical formal linguistic, there was the idea that we have three different layers of language, right? I mean, you know that, yeah? On the lowest level, we have the syntax, yeah? So we can talk about syntactic structures in terms of grammar, syntax trees, and we can build sentences that are syntactic, like colorless green ideas sleep furiously, but that don't have a lot of meaning, don't have a lot of semantics, right? And on semantics, we are talking about what you are talking about all the time, entities, relations, things, yeah, knowledge, inferences, and so on. So we know Platon, Leibniz, Wittgenstein, and so on. And then we have pragmatics, what we're doing with language, right? When I ask Nieves, can you open the window? Then I don't want to have the polite answer, yes, I can. But I mean, this is a request, right? I want her to open the window. That's what we're doing with language, right? It's still different from the other layers. And when I entered the scene, so we were trying to get hold on semantics in a very, very precise, logically precise way. For example, taking set theoretic interpretations of how nouns and adjectives would find together, right? For example, if you say red elephant, then you're looking at the intersection of red things and elephants, right? I mean, what I'm talking about is a concept that lies in the intersection of these two concepts, red elephant. When I'm talking about a small elephant, then it's actually not in the intersection of elephants and small things, yeah, because a small elephant is in the intersection maybe of large things and elephants, but it's still a subset of elephants, right? That can be safely assumed when I talk about a small elephant. An alleged elephant is not even within the set of elephants. Yeah? It's something outside the sets of elephant, but it can be mistaken or taken for an elephant, right? So that's what we were busy with in the good old logic days. And this is now my favorite slide. All gone, yeah. I mean, all these insights, they were nice, yeah, but they are seemingly, and this relates to the title of my talk, no longer of use. Instead, what we have in natural language processing and what we have developed in the last like 10, 15 years is a very flat processing of language on the word surface. Yeah? So the word is the primary thing to study, right? We are not looking into the words and what there might be a meaning behind the words. We forget all about this. It's only words. Yeah? There's words, and we use them as primary objects. Right? There is very little word knowledge and hardly any linguistic knowledge in use, I would say. And maybe ChatGPT, now we can ask the question again. Maybe we are getting back some of it, and that could be a good starting point of a discussion, but probably better over a beer tonight rather than here in this room. But what is really important to me is to once more think of this middle point. There is a trade-off between control. Yeah, when I know what I do, just like with the elephants and the adjectives and so on, when I have a lot of control, the performance is usually lousy. Yeah, and when I have little control, I put all the data in and shake a big model, then the performance is great and things scale. Yeah, and this loss of control, I mean, it can be like pursued over the last years if we start from symbolic knowledge processing through classical machine learning up to the neural networks that we are seeing. And this is the good thing today. I probably don't need to explain to you what I mean by symbolic knowledge processing, but because that's what you are all busy with, we are talking about knowledge graph, triples, basic facts, who did what, to whom, info boxes, and so on. there we have a lot of control. We know what we're doing, but I mean, linguistically, it doesn't. I mean, I can do only a tiny talk about a tiny bit of language, right? And this is also where our classical chatbots fall into, our smart assistants, our telephone banking systems. Everything is scripted, everything is under control, but scalability is, in terms of language processing capacities, very much limited. And then came the idea, how can I get the hold of the meaning of words, of the semantics of words, when I don't want to link them manually and don't want to build ontologies and don't want to build this information. And then came the idea, no, I still have to try to point, no, I don't point, to understand words as vectors. Yeah, and in the first round, if you wish, you would take two words like mouse and cat, and then you would go and would take 4 different texts, text A, B, C, and D, and then you would count how often does mouse appear in these texts and how often does cat appear in these texts, and then you count 2 times, 3 times, then you end up with a vector of 2330 for the mouse and 0414 for the cat. You can, maybe the first document is from the computer domain, right? You have mice, but you don't have cat. And the second text is maybe from the zoological domain, so then you have both, so on. And then you could take these vectors and you could count and calculate with them. Yeah, you could estimate the meaning of a sentence, of a paragraph, of a text, and then you could find the right answer for a query. I mean, by finding the best document that might give an answer, or the first search engines work this way. So I would say, summing up, we had a little bit of control left, yeah. So we could look into the vectors, and there was also a lot of manual feature engineering, yeah, like building keyword lists, stop word lists, and maybe also when I wanted to do sentiment analysis on reviews, then I would have to say if hot is a positive or negative adjective, right? A hot coffee is positive, a hot beer is probably not so positive, and there was a lot of manual work still involved, but many things were also falling through, yeah, like negations, modality, everything that needed word order fell through because there was basically a bag of words approach. Take all the words in one big bag and start the calculation. And then comes, I mean, the next level of word embeddings. I mean, the next level of vectors that we will talk about in a second. You can even calculate with, right? I mean, if you take the vectors like for king and woman and man, thank you. Then if you take the vector for king and you subtract man and you add woman, then you get the vector king minus man plus woman, and this vector is like the vector for queen. Yeah? Like just by counting the words, I mean, you model the meaning of the words in some way or other. And these vectors, I mean, not the vectors like like in the mouse and cat example, take 4 documents or take Wikipedia and count how often it appears, but in the neural networks, I mean, this idea is taken to the next level because now I understand the word in the real surrounding of, I mean, in the real cloud of words next to it, around it, right? Not just in some documents, but in all documents. All the training documents that ChatGPT would devour, would take in, it would take the words, would mask one word, and would try to guess that word. I mean, you've heard that, right? I mean, this is the idea, the perfect, so to speak, idea of taking the idea of word embeddings and distributional semantics to the highest level, which means, doesn't mean, but I have very little control. I cannot look into these vectors anymore. I don't have any chance to find out what's in there, but the scalability is bombastic, yeah, and they just work. And also within the last like 2 or 3 years, I mean, we've seen changes in this domain again. I mean, we started out with task-specific models. We would build one model, neural model for translation, one neural model for sentiment detection, one neural model for summarization, one neural model for this or that. And then came the pre-trained language models like BART and so on. I mean, BERT and the other pre-trained models that had the linguistic knowledge but not yet the word knowledge. Yeah, then we would use those models to model the linguistic part, and then we would just fine-tune them for translation, for sentiment detection, for this and that. And then came the pre-trained big models that brought the linguistic model knowledge and the word knowledge. And then the only thing you need to do, I mean, is prompting. I mean, everything else they bring. And this is my last slide now. Don't forget, I mean, just always don't forget that it's not only the large language model, like in GPT-3 or GPT-2, but there's a lot of human and manual preference training so that they listen to us, that you can have the dialogues with the models, that you can refine things, and there is a lot of harmless training has been done to these models by humans. Yeah, I'm coming to an end. So whenever the model does something, you never know whether it's just emergent from the language model or whether it has been fine-tuned and trained on top of it. Yeah, so when it does is very good in some programming task, it might be due to the lot of preference training, and you can improve it if you do it with your specific task. And if it sounds like a moral, integer, and wise model that says, oh, I cannot talk about abortion because this is a critical topic, this might not come out of the language model, yeah, like Phoenix from the ashes, but I mean, it's like the people have trained the model that way, right? Don't forget these things, these models, these are not, they are not the way they are just out of the blue. There has been a lot of manual work that put into these models, but yeah, let's keep it at that. Thank you.
Yeah, thank you, Ayosha, for this interesting presentation again, and also for paying attention to the time. So, are there questions? My question that's very is now NLP at the end or not? Like this was your topic, right? So we want an answer.
I mean, the answer has two sides. I mean, one side is at the moment, if I'm speaking here as a German or as a European, as we are don't have the technology here, but the hyperscaler in the US and maybe in China have it. It's difficult for us at this point, to be honest. Yeah, just I mean, in terms of hardware infrastructure and everything you would need for research, and I hope that we would find niches where we would have a chance to do real fundamental or what kind of research in the future. But I mean, if we are doing badly in Europe and if we don't manage to build up this infrastructure fast enough, then we might become users of the technology, observers of the technology, right? I mean, this was a little bit more my provocative title rather than the question if experts are needed.
And another question is, since like you showed us how we can do vectors from words, or that we can do it in general, we can also do that for terms in RDF, and we can also do RDF to vec and tools like that. So would you also see a threat or like that our vocabularies, our technical vocabularies that we use in RDF will not be of relevance in some kind of a future, or will they still be needed in the way how we like try to manage them with a lot of effort at the moment?
This is not a really honest answer because I can't tell, but I have an avant-garde idea. I have an avant-garde idea that natural language becomes the interface between everything, so that your text program asks your printer, I need to know how much money or how much ink did we buy this, or did you order this year, so I can fill it into the text form, right? So the idea is that all machines and all machinery, everything can talk through chat functionalities in the future, and we as humans can just observe it and can see if it went right or wrong, right? I mean, but this is just an avant-garde idea, but I think that natural language might become a more versatile interface in the future. Again, if you wish, like Montague, 1972, English as a formal language. Let's see. Yeah.
Thank you very much. Thank you. So Ken, you're over there. So Ken is from Fraunhofer Institut für Werkzeugmaschinen und Umformtechnik, IWU. What's the English name? I don't know if I'm on
Fraunhofer Institute for Machine Tools and Forming Technology in Chemnitz.
In Chemnitz, okay. So our Leipzig Semantic Web Day also covers Chemnitz, as we see. No, many more places as well. So linked factory is storing and querying production data at scale. Stage is yours.
Thank you. Hello, my name is Ken Wenzel, and I'd like to give you some insights on linked factory, a concept that we developed to manage data in production companies. Those production companies use software to monitor and control their production processes. And if you put machine learning into the mix, you need good data architectures for refining the data which is required for training the models and for using them afterwards. And when creating those data architectures, you face the usual problems. You have different subjects like products, processes, resources, and you also have heterogeneous data from different sources. And we think that it is a good approach to use linked data principles to create such data architectures for describing the structure of the processes, products, and resources on the one hand, and the measurement data on the other hand. And you could use Sparkle for joining both worlds and create a unified view over your data. I like to start with a small example. You can see here a miniature press that we use for demonstration purposes. It could create coins, for example, or small soup bowls or something like this from metal. And this press has a structure. This is only part of the structure. It's composed of a frame, multiple columns, but you can also see that there are sensors which are attached to the columns. And those sensors produce the data shown on the right. This is a force distribution for one stroke of this press. The force gets bigger and then falls down after the stroke. And we can use RDF to describe the structural model. This is pretty simple. We can just introduce a has-part relationship, and we can introduce some types like manufacturing press or the strain gauge type that describes the sensor type, and we create just this hierarchical model of the press in RDF. That allows us to query the structure and, for example, to find all sensors which are contained in the machine just by using some property paths and by filtering the sensor type, for example. And for this example, we get one sensor, exactly the strain gauge sensor, which was included in the structure of the press. But now comes the important part. We have measurements of those sensors. Those measurements are usually high-resolution data that is collected in a resolution of 2 to 4 milliseconds, and you can see here multiple strokes of the press where force data is collected at different points. And now the question is, can we store this data in RDF? And if we store this data in RDF as shown on the upper right, we need at least 3 triples or quads per data point. That would result in at least 96 bytes per data point if we use only one index structure, only one access path. So that means we store 2 values, which would require the time value and the measurement value, which would require 16 bytes, but we require at least 96 bytes. I think in unusual triple stores even more to represent those points. What can we do to solve this? We could extend our triple with a 4th or the quad with a 5th dimension, that the timestamp. We could just add the timestamp to the triple or to the quad. So we pick one element from the structure, the strain gauge, as shown in the middle here, and we use a predicate URI and combine it with a timestamp. And we use those 3 parts as a key in a key value store, for example, but we could also map it into a time series database. And we use this key to store the values. And when using this structure, for example, in LevelDB or RocksDB, we just need 10 bytes per data point for storing this data. because level DB also has prefix compression, so we don't repeat the bytes we already have written. For example, subject predicate is just compressed by the prefix compression. So this is a good storage mechanism for storing those time series data. Now the question is, how do we retrieve this data? We like to use queries with Sparkle. So we see both data sets, the data set with the structural information and the data set with the time series information as a virtual graph. And we introduce a special custom federated service called Quinn. Quinn stands for 5. And the green part is the same. We can just query the structural information, and we add the custom service Quinn for querying the time series information, and we extend this by magic properties like Quinn time and Quinn value to access the time series data. So we can query the data which is required for this diagram shown on the right. So far we have a good solution for representing and aggregating machine data for creating such dashboards as shown here. But we can do even more with this data model. Currently, or up to now, we only have investigated the machine-centric view, where we have a press with strokes and forces and so on. But we can also represent process-centric data. For example, each stroke may have an associated workpiece or some parameters like a maximum force and so on. And we can also represent part-centric data with this approach. To use this approach, we have created a simple HTTP an API and with only 3 endpoints, values, properties, and descendants, and a simple JSON LD-based data format which is able to represent simple data types, but also records as nested JSON structures and URIs for linking the data. I like to show you some examples. In a hot forming use case, hot forming parts are required structural parts for every car. For example, we can describe here the workpieces which run over a machine at a specific point in time and link those workpieces to the description of the workpiece itself and then to the raw material this workpiece was made of, just by using the subset of JSON LD. Later on, we can query this data. Here we use not the structural information, but the green part is a special vocabulary used for describing, for example, the properties of a workpiece, and we only want those properties which are related to quality inspection. And afterwards, we can query the time series database for the last 20 properties which run over press 1, for example, and their quality inspection related values, and we can compose a view with this. Another example is we can also resample data by pushing down operations to the API, like the average operation and an interval. So we can resample data to 200 milliseconds, for example, and create such tables which are required for feeding machine learning models. And we can also store more complex structures, like for this B-pillar part from a car, the measured temperature. So, for example, we can also store points, or we can also store nested structures to describe rectangles. And the query engine allows to reconstruct tables out of this data by using an RDF collections, for example, and it recreates those tables as shown on the right side. This is architecture blueprint. This is almost my last slide. This is architecture blueprint. There we usually have a production system with an edge PC. This edge PC has a historical data service, and we have a central linked factory pod or multiple linked factory pods with this Sparkle engine that accesses this HPC and the data contained there and can aggregate the data. And we have a control or a data loop through a Kafka cluster and an analytics pipeline which has access to this Sparkle engine through the linked factory pod to get more contextual data. So if you want some more information, you can look up those links here. And this is all from my side. Thank you for your attention.
Thank you very much, Ken, for this talk about how you deal with time and also with space, like in terms of storage. Questions from the people? I mean, I have already questions that I hope that I can ask them. So, since you spoke about quads as well, and you add just another column to the triples, why didn't you just use the context part, which is common for time series data and RDF archives to use as well for things like timestamp?
This is a good question, but it wouldn't solve the problem that we need at least 3 triples to describe one data point. 1 triple for the time, 1 triple for the value, and 1 triple for associated with blank node with time and value to the resource, for example.
No, you would put the time into the context, and then you just have...
So you use it to, for example, at least maybe 2.
Okay, so maybe I don't get it in this point, but I thought it would just make it 1 triple then, to have like the value, subject, predicate, value, and the time in the context.
Yes, you are right. But even if you do this, you can't use the prefix compression. You can't use sorted lookups because you need an index that is sorted by the context when. So you need another specialized index sorted by the context and so on.
Okay. Questions from people? No? Okay, so then as I asked in the session before, there's RDF star, not actually the elephant in the room, as we spoke about elephants before, but I would assume it would just make your storage problem bigger. Would it help to solve, or would it not help to solve?
I think in this case it would not help to solve the problem because you have one more indirection or one more data point to store, but it will help in any other or in many other provenance problems that you currently have, and that can be solved by RDF star.
Okay, cool.
But I wanted to mention that the linked factory architecture is not only about storing the data, but accessing the data via Sparkle and via a common small API, not about the storage.
Okay. And how does it, like my last question, and Paolo, you can also already come to the front if you like. So how does it relate to, like there's a lot of related work on RDF archives and time series databases for RDF. So how would your work fit into this topic, or would you say it's a third topic, or would it somehow be part of these versioning systems and archiving systems?
Yes, it's some kind of archiving system, but not for RDF data, because we only support one access path. Only you need to know the subject beforehand, and then you can traverse the properties and the values through time. Not other way around. You can't search only for time, or you can't search only for property values, which is often possible in archiving systems, for example.
Okay, cool. Thank you very much. Let's thank the speaker again. And now our final presentation in this session will be by Paulo Ricardo Viviorca do Carmo. I'm happy that I can say all of the names since they're in the program. And he will present the Dino Bio project. Stage is yours.
Thank you, Nathanael. Okay, here I'm going to present about our project, Dino Bio, which is discovering new natural-inspired products from Brazilian biodiversity. I work in HTVK, but I am originally from Brazil. And the idea of this project is to first organize the current and future research efforts regarding natural products within Brazilian biodiversity and provide a single knowledge graph or knowledge base for this type of data, because currently we have multiple databases that you can access natural products and chemical compound data, and this is not efficient, especially if you are a chemist that doesn't understand much of how to query. They usually don't have the effort and the resources to do this type of research. So our team is composed. This project also has some people working in Brazil from Unesp and USP, and us working here in Germany. So first and foremost, why we need automatic extraction for a project that is focused on having a knowledge base of chemical compounds. So most of these chemical compounds from natural products are first published in papers or patents, mostly papers. And to read and get information from these papers is very cumbersome. So knowledge graphs helps us to organize the information, the important information, in a structured manner, and also reusable and indexable. But to keep these knowledge graphs up to date is also very cumbersome, since you normally would also need humans to keep reading these papers and extracting this information, which is what we don't want. So to explain a little bit about how we do this, I would talk about text embeddings, but thankfully a colleague presented a really good explanation before it. So I'll go directly on what are graph embeddings and how they come to be, mostly because of text embeddings or word embeddings before. The method below is deep walk, which takes a graph and does random walks through it and uses this information from the random walks directly in the same structure from word to vec. So it treats the nodes as text, and therefore you can get the embeddings, the vectors, from nodes in the graph. And this concept can be combined directly with text embeddings from language models, for example, with embedding propagations. And this concept can be done if you have one or more nodes that contain some textual data. You can use them to propagate through the network, and in the end you have vectors for each node in the same vector space from the original language model, which is interesting for us to do the information extraction from the text. So our data set has, at the moment, 2,521 natural products, but we are scheduled to receive a new version with more from that were discovered in Brazil. It was originally built by 2 chemistry PhD students that reviewed the papers, and they annotated mostly these 5 components: compound name, bioactivity, species, collection, the local where they find the species in Brazil, and the method, the chemical method that they need to use to extract the chemical compound from the species, being it a plant or an animal or fungus. The original database is called NubiDB, and we performed semantic certification under NubiKG, which currently can be accessed under nubi/kg.aksv.org. The QR code takes you there. And our natural product knowledge extraction method is called Natuke, and it uses knowledge graph completion after we do the graph embedding methods from the central node, there is a paper that contains the text, to the other characteristics that we want. And we also created some other nodes that support us during the generation of the embeddings. For the evaluation of this task, we wanted to have a dynamic evaluation, so we have 80% of the data for testing and 20% for training the first stage, until 80% to train and 20% to test. Because we want to see how the results and the model evolves throughout time if we have more data already extracted in our knowledge graph. So the metric we used is called hits at k, which is a really interesting metric if you have a single ground truth for many exposed ones, and you can set up different k and see until how many candidates it's manageable for the user to sift depending on the proposition. So in the 28th of May, we also hosted a workshop in ESWC to try and get some new ideas on how to improve our current Natuki that was first published in ICSC in the beginning of this year. So we had 3 ideas that were awarded. First, Bushan and his team created a used the BFS-driven knowledge graph embedding model and added. And second, Stefan and Ishwan used name identity recognition before the embedding and topics generation to try to get better information to the model. And our first place used ChatGPT to add extra information to the text. And the 2 of the teams here are here for the first place, down there. So here I'm going to present quickly some results from the original Natuki and also for the ideas. So first, why we use the different K values here. We had chemical compound, bioactivity, species, the location, and isolation. All of those had very different amounts of data that you could have. So it makes sense to have a larger evaluation, a larger window that you can consider the answer to be correct for the chemical compound and the isolation type, which chemical compound has way more unique values. And the K was decided empirically, running from 1 to 50 and locking when any of the evaluation stages for many of the models surpassed 0.5 in the original Natuki. So for the first result from Bushan, this method here, it performed really good in the tasks that were really challenging because you had I have a theory on why this happened, but I didn't have the time yet to analyze if my theory is correct. So if you want to talk to me later about this, maybe in the semantic beer garden we can discuss. And but it didn't perform well on the other, which we're going to see. For the NER, it as we were expecting, it improved the results a little bit in most of the cases because it gave better data for the graph embeddings and the text embeddings to filter later. And ChatGPT, which we're going to see, but in this case specifically with MetaPath2Vec, it didn't perform very good, but with others it had some good performance. So now for bioactivity, we see that BFS2Vec not only did not perform really well compared to the other methods, it also lost performance as we had more trained data, which is not expected. But with NER, for example, we had some improvement upon the original Natuki. Especially you can see that in the third evaluation, on the third and in the fourth evaluation stage, it fell a little bit, but on the third it was quite better. So, and for ChatGPT, it surpassed the fourth evaluation stage from the original Natuki in the second already. So it was quite interesting for this case. In the collection species, we had a behavior similar to the original one to the compound name extraction, and in all scenarios, here it has more similar to bioactivity, and I think now the most interesting one is the isolation type, where it's the only one that uses the heat set 1, which is basically accuracy, and especially ChatGPT had a really good improvement in the third and fourth evaluation stages. So some concluding remarks. With the new ideas, the IFN, which is an embedding propagation method, maintains its good in performance when completing, especially related more to the chemical compounds. On the other hand, BFS2VEC has showed exceptional performance on the more challenging scenarios, where before MetaPath2VEC was the best graph embedding method. And both NER and ChatGPT improved most scenarios by quite a margin. We also want to remark for future work that all these three ideas can be implemented once, so we have a very clear path for research on improving Natuke. And secondly, we aim to transform the extraction method into an open, pre-trained automatic knowledge extraction for natural products. And yeah, so we also want to have the feedback from the users. Some references, and that's it.
Thank you very much, Paulo, for the presentation on this biodiversity problem, what I think also fits very well into the overall topic of the Data Week, as we started with the European Green Deal, and here at the Semantic Web Day with the whole technology you're working on. So any questions from the people? So that was a lot of hardcore model things and challenge results. So I didn't fully understand it.
Yeah, we can talk later over a beer or two. Yeah, I think it's quite a challenge because it uses a lot of different concepts together, and yeah, I think even during the challenge to get new people come with new ideas, it was always complicated to introduce them first to the algorithm, and then have their contributions back later. So yeah.
You also have the prize winner back here, right?
Yeah, the first place, yeah.
In the people, in the audience. Okay, so if there are no questions, as I said, I can't contribute constructive questions here. Let's thank Paulo again. You have a question. Why didn't you raise your hand earlier?
I don't have a question. I just would like to, thanks to Essenza, that was our partner in development of the project and also the challenge. Yeah.
NubiKG especially, I'm not the one that uses corporate memory, but yeah, Ishwan really likes the tool, so, but he's not here to speak on it today. Yeah.
So now let's head over to the Best Poster Awards.
Yeah, and to the closing ceremony. I have the pleasure to lead the closing ceremony of the Semantic Web Day. We have slides for that as well.
Müsst ihr hier mit drücken?
Not sure. No. So, yeah. Welcome to the closing ceremony. My name is Sebastian Trump. I'm CTO of the Essenza GmbH. And this closing ceremony consists of two parts. So first of all, I can give you a wrap-up of the Leipzig Semantic Web Day. So this 11th Semantic Web Day was very successful. Beside this one keynote we had and the free session with the 15 talks and 27 speakers, including the students, we had 10 posters, and you voted a lot, yeah, so 90 votes for the best design poster, 80 votes for the best semantic web poster, and overall we had potentially over 200 visitors today. This is a record for the Semantic Web Day overall, and this is also the best day in the Data Week so far. So Data Week is a whole week, so maybe tomorrow it's even more. And yeah, this closing ceremony contains two parts. So, and the second part is the nomination or the giveaway for the Best Poster Awards. And the first award was the Best Design Poster Award. As I said, you voted with your red dots from your badge, and you did it a lot. Thank you for that. And the winner for this Best Design Poster Award is das Sichtbarmachen von Autoren und Publizisten im Straßennetz der Stadt Leipzig von Clara, Matthias und Heinrich. Are you in the room? And Thomas, are you in the room as well? I mean, congratulations to your students. And now we come to the Best Semantic Web Poster Award. Also here it was quite, the race was clear at the end. Yeah, I looked over all the breaks, and at the end the winner was clear. So the winner for the Best Semantic Web Poster Award is Lukas Westholt with estimation of public transport locations in Leipzig. Okay. Yeah, and the last important notice from my side is to give you a hint where you have to go now, or in a few minutes. So we have it now, I think, 5:15, and until 6 p.m. you can go these 450 meters to the Moritzbastei. So you see here the map of the city center, and we are at the Martin Luther Ring 4, and you have to go just when you come out to the left, go to the Moritzbastei, and then we invite you to the Semantic Beer Garden, which is also a tradition for the last 5 or 6 Leipzig Semantic Web Day. Okay. Okay.
So, just I'm looking for one more thing. Okay, so that's not a real slide, but that's a real the logo for Data Week 2024. So actually the Leipzig Semantic Web Day will also be part of the Data Week next year, and we already know the date for the week. It will be also here in the Town Hall of Leipzig, and it will be from the 15th till 15th
16th, 17th, 18th, and 19th of April next year. So it will be already in the spring, not in the summer as this time and as last time. And so we welcome you in the spring next year. So not a lot of time to wait for the next data week. And on Wednesday, there will be the Semantic Web Day again. So on 17th of April, 2024, you can mark it in your calendar right now already. And then in the evening, there will be beer garden. So, yeah, thank you to all the speakers today for this nice Semantic Web Day. And we had the chance to discuss a lot of semantic technology topics. And we had a good discussion and also very valuable contributions by the students. Thank you all and see you later. Das wäre ganz schön klein.